ಮಾಡ್ತಾರೆ.
ಈಗ ಎಷ್ಟು 10 ಗಂಟೆ 5 ನಿಮಿಷ ಕರೆಕ್ಟ್
10 ಗಂಟೆ 10 ನಿಮಿಷ ಆಯ್ತು.
10 ಗಂಟೆ 11 ನಿಮಿಷ ತೋರಿಸ್ತಾ ಇದೆ ಇದರಲ್ಲಿ.
ಹಾ, ಸೊ 100 ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ ಫುಲ್ ಆಗಿ ಹೋಗಿದ್ದಾರೆ. ಈಗ ನಾನು ಯೂಟ್ಯೂಬ್ ಲೈವ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಈ ಸೆಷನ್ ಅನ್ನ ಯೂಟ್ಯೂಬ್ ನೋಡಬಹುದು. ಅದರ ಲಿಂಕ್ ನ ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಹಾಕ್ತಾ ಇದ್ದೀನಿ ನೋಡಿ ಸರ್.
ಇದು ಅಲ್ತಾಫ್ ಅವರು ಅನ್ಸುತ್ತೆ.
ಹಾ ಹೌದು ಸರ್, ನಮಸ್ತೆ.
ನಮಸ್ಕಾರ.
ಈಗ ಎಷ್ಟು ಅಲ್ತಾಫ್ಗೆ ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಅಂದೆ ಯಾವಾಗ್ಲೇ.
ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಸರ್, ರಿಪ್ಲೈ ಮಾಡಿದೆ.
ಮುದುಕರಿಗೆ 2 ಸರಿ ಹೇಳ್ಬೇಕಾಗುತ್ತೆ.
ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಸರ್.
ಗುಡ್ ಮಾರ್ನಿಂಗ್
ಗುಡ್ ಮಾರ್ನಿಂಗ್.
ಗುಡ್ಸ್ ಮಾರ್ನಿಂಗ್ಸ್ ರೆಕಾರ್ಡ್ ಇರುತ್ತೆ ಒಳಗೆ.
ಸೊ
ನಟರಾಜ್ ಬಂದಿಲ್ಲ ಇಲ್ಲ,
ಅದೇ ನೋಡ್ತಾ ಇದ್ದೀನಿ.
ಎಲ್ಲೋ ಕೇಸನ್ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ.
ಬಂದ್ರು ಅಂತ ಕಾಣುತ್ತೆ.
ಅಯ್ಯೋ ನನ್ ಸೆಕೆಂಡ್ ಏನು ಅಂತ ಗೊತ್ತಾಗಲಿಲ್ಲ, ಯಾರು ಅಂತ ಗೊತ್ತಾಗಿಲ್ಲ.
ಕಾಫಿ ತಿಂಡಿ ಎಲ್ಲ ಆಯ್ತಾ ರಾಘವ? ಕಾಫಿ ತಿಂಡಿ ಎಲ್ಲ ಆಯ್ತಾ?
ಇಲ್ಲ, ಇವತ್ತೇನೋ ಸತ್ಯನಾರಾಯಣ ಒಬ್ಳು ಕೂತ್ಕೊಂಡು ಸತ್ಯನಾರಾಯಣ ಪೂಜೆ ಮಾಡ್ತಾ ಇದ್ದಾರೆ.
ಮಾಡಿ ನಂಗೋಸ್ಕರ ಅಲ್ವಾ?
ಅಯ್ಯೋ
ಮಾಡಿ ಮಧ್ಯದಲ್ಲಿ ಎದ್ದು ಬರ್ಬೇಡಿ.
ಇಲ್ಲ, ಶುರು ಮಾಡಿರ್ಲಿಲ್ಲ ನೋಡಿ, ನಿಮ್ಮನ್ನ ನೋಡಿ ಹೊರತು ಶುರು ಮಾಡ್ಬಾರ್ದು ಅಂತಿತ್ತು.
ಸರಿ
7:30 ಶುರು ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ, ಬಟ್ ಆಗ್ಲಿಲ್ಲ.
ವಹಿಸಿ.
ಗುರು ಬ್ರಹ್ಮ ಗುರು ವಿಷ್ಣು.
ಎಲ್ಲೋದ್ರು ನಟರಾಜ?
ಇರ್ತಾನೆ, ನಮ್ಮ ಕಂಪ್ಯೂಟರ್ ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ಚೆಕ್ ಅಂತ ಬಂದ್ಬಿಡುತ್ತೆ ಕರೆಕ್ಟ್ ಆಗಿ.
ನಾನು ಸ್ನಾನ ಮಾಡಿ ತಿಂಡಿ ಗಿಂಡಿ ಎಲ್ಲ ತಿಂದು ಎಲ್ಲ ಮುಗಿಸ್ಕೊಂಡು ಕೂತ್ಕೊಂಡಿದ್ದೀನಿ.
ನಾನೊಂದ್ 2-3 ಲೆಕ್ಚರ್ ಮಾಡಿದೀನಿ ಇದ್ರಲ್ಲಿ, ವೆಬ್ ಅಲ್ಲೇ ಅದರಿಂದ ಇದು ಝೂಮ್ ಅಲ್ಲೇ ಮಾಡಿ.
ನೀನ್ ಬಿಡಪ್ಪ ನೀವೆಲ್ಲ ಪ್ರೊಫೆಷನಲ್ಸ್. ಆಮೇಲೆ ನಿನ್ ಯಾವ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಏನ್ ಕೇಳಂಗಿಲ್ಲಪ್ಪ ನಿನ್ನ. ನೀನು
ಕಷ್ಟ ಆಯ್ತು ಅಂತ ಹೇಳಿ ಮಾಡಕ್ಕೆ ದೇವರನ್ನ ಸರಿ ತೋರಿಸ್ಬಿಡಿ.
Students, there is one request nimage. I will be removing 4 or 5 participants from the participant list right now. So I'll ನೀವು ಸ್ವಲ್ಪ ಹೊತ್ತು ಆಮೇಲೆ rejoin ಆಗ್ಬೋದು, because the limit is 100 and HR sir is yet to join. So please don't mind, I am removing Vibha from B section. ನೀವು ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಜಾಯಿನ್ ಆಗ್ಬೋದು, ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಹಾಕಿದ್ದೀನಿ ನೋಡಿ. And Abhiram,
Sir,
Abhay Singh.
Sir,
Yes?
which Abhiram, sir?
Okay, not Abhiram. Abhay Singh. Abhay Singh. 100 participants ಆಗೋಗಿದ್ದಾರೆ. And ನಮ್ಮ next guest ಜಾಯಿನ್ ಆಗಕ್ಕಾಗ್ತಿಲ್ಲ.
Yes, good morning.
Good morning, sir.
How are you, Mr. Altaf?
I am good, sir. I am good.
So you are seeing me?
Just a second, sir. I'll. How do I pin sir's video? I'm trying to find you in the participants list, sir. Give me 1 minute so that I can pin your video. Sir, video off ಆಗಿದೆ ನಿಮ್ದು.
Video off ಆಗಿದೆ.
ಹಾ, video off ಆಗಿದೆ.
ಬಂದೆ. ಈಗ
ಇವಾಗ ಕಾಣಿಸ್ತಾ? ಮಾರ್ನಿಂಗ್ ಸರ್.
ಗುಡ್ ಮಾರ್ನಿಂಗ್ ನಟರಾಜ್.
ಡಾಕ್ಟರ್ಗೆ Morning.
ಯಾರು ನಟ ಹತ್ರ ಮಾತಾಡ್ತಿರೋದು?
ಇಲ್ಲ, KVG ಸರ್.
ಓ, KVG. ಮಾರ್ನಿಂಗ್ KVG. ಹೇಗಿದ್ದೀರಾ? How are you?
Fine, sir.
Thank you. Sir, I'm waiting for Nataraj sir to join.
ಎಲ್ಲಪ್ಪ KVG ತೋರಿಸು ಸ್ಕ್ರೀನ್ ಮೇಲೆ, ನಂಗೆ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ.
KVG ಸರ್ ನ ಒಂದ್ ನಿಮಿಷ ಅವರಿಗೆ ಸ್ಪಾಟ್ ಲೈಟ್ ಮಾಡ್ತೀನಿ. ಇಲ್ಲಿದ್ದಾರೆ. ಕಾಣ್ತಾ ಸರ್?
ಇಲ್ವಲ್ಲ.
ಹೌದಾ, ನಾ ಅವ್ರಿಗೆ ಸ್ಪಾಟ್ ಲೈಟ್ ಮಾಡಿದ್ದೀನಿ.
ನಾನೇನ್ ಮಾಡಕ್ ಬೈ ಚಾನ್ಸ್ ಇಲ್ಲಿ?
ಸರ್ ಮೇಲೆ ರೈಟ್ ಸೈಡ್ ಅಲ್ಲಿ ವ್ಯೂ ಅಂತ ಆಪ್ಷನ್ ಇರುತ್ತೆ ಮೇಲೆ, ಟುವರ್ಡ್ಸ್ ಯುವರ್ ರೈಟ್.
ಬಂದೆ. ಮೋರ್ ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್, ಸ್ಟಾಪ್ ವಿಡಿಯೋ, ವ್ಯೂ ಎಲ್ಲ ಬಲ್ಲೇ ಇಲ್ಲಪ್ಪ. ಮ್ಯೂಟ್, ಸ್ಟಾಪ್ ವಿಡಿಯೋ, ಶೇರ್ ಸ್ಕ್ರೀನ್, ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್, ಮೋರ್, ಲೈವ್ ಯೂಟ್ಯೂಬ್, ಝೂಮ್. ಹೋಗ್ಕೊಳ್ಳಿ, ಶುರು ಮಾಡೋಣಪ್ಪ.
ಹಾ ಸರ್, ಎಸ್, ಐ ಥಿಂಕ್ ವಿ ಕ್ಯಾನ್ ಸ್ಟಾರ್ಟ್.
ಪರವಾಗಿಲ್ವಾ? ಮಾತಾಡ್ಲಾ?
ಎಸ್ ಸರ್, ವಿ ಕ್ಯಾನ್ ಸ್ಟಾರ್ಟ್.
Good morning to every participant, and we are meeting in a post-COVID era. Therefore, you should know all the protocols. You should be wearing your mask always and keep the social distance correctly, 1 meter away. That is the important instruction to learn first, because the topic today is how to learn. Incidentally, I am always learning. It's very difficult to say how to learn, Always, I'm always learning. But the how to learn is again come from learn concept. There is learn how to learn. Interestingly, this is exceeding the good subject under which we are conducting in a webinar seminar under the auspices of B.V. Jagadish Science Center. And in fact, this science center is built for such purposes. It's not for really textbook work. Apart from textbook work, whatever you do in science, experiments and other things, you can do at this center. This was built by one of our more students of the National College Basuri, National College Jayanagar, Mr. B.V. Jagadish, maybe about 12, 30, 15 years back, 15, 16 years back, And such a center we are using today for this latest technological event, I'm extremely happy about it. And in this event, we have got very, very interesting things, First, we got Professor KV Ganesham. He was a very distinguished professor of chemistry in our college, and he was speaking about the love of chemistry. I think everybody should love chemistry, because of chemistry, life is there. Then, subject starts from electronics, Professor Malte, electronics for you. Then the next day, Dr. A.S. Govind will speak on physics in everyday life. Without physics, nothing is there, And then Wednesday, we got, of course, the latest one in the sense, computer science, the most important thing for us, Mr. T.G. Srinidhi. He will do something regarding start with C. Then Professor V. Venu Gopal will speak on Samskruta Ellarigagi. That's interesting, Samskruta, yaro elite people ankondo, but it bhala interesting agi Samskruta Ellarigagi marta idare. That will be interesting. Then on Friday, we have got Mr. Sri Raghavan speaking on Number Nagar. That is also extremely interesting, Number Nagar. Then Professor Vanamala V, who are working in National College Jayanagar long back, will speak on how not to learn English. So when you discuss how not to learn English, maybe you would have ended with learning English, That is the beauty of it. Then our another extremely good professor from the National College Jayanagar, Dr. H.S. Raghavendra Rao, Ellarigu Kannada. That is also equally important, We are living in Karnataka, and everybody should know the language of the state. In this state, the language is Kannada. Then again, computer science, I think Mr. TG says you continue start with C. Then at 12:30 p.m., Professor Mr. Faruqi will speak on beauty of biology. In fact, what you are seeing is actually the beauty of biology. You know? Actually, physics, chemistry, mathematics, biology, the basic sciences and the applications are most important. We are stressing on that one here. In this time, what happens is it's very difficult to call for a conference of 100, 200, 10 people in an open space because of the existing COVID circumstances. And this webinar is coming just handy, you know, because this is what we need. And this is formulated by the most important person here is Professor K.S. Nataraj, Director of B.V. Jagdish Science Center. When he called me and asked me about this, I was very happy and told him, I say I am a participant in the sense I am learning. No, sir, I have to give some inaugural address. He told me that's what I am doing it here. And this is possible, all these are possible because of my colleagues, Professor S.N. Nagaraj Reddy, Dr. P. Sadanandamaya, Secretaries of the National College. Where Sadanandamaya ever remembered, you know, on that campus, the entire PU college building is built by Dr. P. Sadanandamaya. Then come the real persons who take care of the college. That is Dr. B.R. Pranita, the principal of the degree college, Professor Sampath Kumari, the principal of PU college. In fact, for all of them, I should heartily welcome and ask them to join this seminar. And when you are joining the seminar, when the subject is learn how to learn. See that how to learn is the most important one, you know. Actually, you are learning and maybe 3-4 days you do that one. That doesn't mean that it's completed. You will continue to learn the subjects. But in that process, if you find that you can use the B.V. Jagdish Science Center, you are most welcome. You can always contact either Professor Natraj or Professor Altaf. Both of them will be ready. Using, there are several senses, you know. Somebody would like to give a short 5 to 10 minute description about the present COVID condition, present status of vaccine or something like that. Then you can use this platform. Or somebody would like to say to the world something new. In fact, Bill Gates, maybe in his speech at convocation speech at Stanford 5-6 years back, has almost envisaged that some type of a virus is going to come on board after 4 or 5 years, which will be much stronger, much harmful than the earlier virus. Therefore, it should be ready. But nobody listened to him. You know what happened after 4 years. And again, today is warning, in the eco cycle, it may so happen, after another 4 or 5 year cycle, you may get a virus which is much stronger, much more harmful than this COVID-19. And for that, we should be ready. Who are the people who should be ready? That is the youngsters who are studying these things. They should do research work. And more than all, they should keep money for that. That's what Bill Gates said about 5 years back, you know. And we never thought of it, this epidemic, and never kept any money also for this purpose. When that came, we shelled down every amount, everything came to stand still. But again, see the Bill Gates advice, be careful after another 4 years. That is what he's saying is, not only the scientific discoveries regarding anything in the world, that's science, but also corresponding what is called as concept of economy. If something happens like that, what should the plan be? And I think youngsters who are listening to me should work toward this side and see that the world is almost always cheerful compared to the earlier years. With this, I wish all the best to the present seminar. Thank you.
Thank you. Thank you so much, sir. Thank you for your enlightening words. And thank you for your modesty of thanking all of us. But we all know that the whole seminar or all the activities of BV Jagdish Science Center would not be possible by your gracious support. We thank you.
No, it's not like that. My support is minimum.
Yeah. Thank you, sir. With this, I think we will go to our first speaker, first lecture of today. Let me check if Natraj sir is here. Sampath Kumari ma'am, are you able to listen to me?
Yes. Yes, Altaf. Are you able to listen to me?
Yeah, ma'am, I am. Good
Okay.
that we are together. Ma'am, if you can just, introduce our first speaker, just say a few words about KVG sir, because Natraj sir was supposed to do it and I don't see him in participants list. Would that be okay?
Okay, yeah. KVJ, sir. Yeah. Okay. Shall I start?
Yeah, ma'am, please go ahead.
Yeah. Well, KVJ, sir was a very, in fact, is a very known name in chemistry and a wonderful speaker and a very good teacher. In fact, I have listened to him once or twice. I had a fortunate one, I think last year I listened to him, his lecture. And we have the privilege of listening to him right now with our students, and our students will really enjoy it. And he's a great teacher. I hope he will do his lecture very enjoyable to students. I think we will welcome KVJ sir. Please, sir.
Sir, over to you.
Okay, shall I start?
Yes, sir, please go ahead.
Yes. Thank you very much, Professor Altaf and Professor Nataraj, Dr. A.H. Ramarao, and my friend, Dr. H.S. Raghavendra Rao, who has joined here. Dear students, I used to love chemistry for Hottepadu. Hottepadagoskara chemistry tagonde. But today, it has become a passion for me to teach chemistry. I'm extremely happy that the title that has been given is Love for Chemistry. I like it. I would like to start my lecture with an anecdote from John Barney. To ask you who is John Barney, most of the students may not be knowing it. Of course, ನೀವು ಪಾಪ ಒಳ್ಳೆ ಹುಡುಗರು, ಯಾರ ತಂಟೆಗೂ ಹೋಗಲ್ಲ, ಬಾರ್ಡಿನ್ ತಂಟೆಗೆ ಹೋಗಲ್ಲ, ಮೇರಿ ಕ್ಯೂರಿ ತಂಟೆಗೆ ಹೋಗಲ್ಲ, ಹೈಸನ್ಬರ್ಗ್ ತಂಟೆಗೆ ಹೋಗಲ್ಲ, ಪೌಲಿಂಗ್ ಹೋಗಲ್ಲ. ನೀವು ಪಾಪ ಒಳ್ಳೆ ಹುಡುಗರು, ಸರ್ ರಾಮನ್ ತಂಟೆಗೆ ಹೋಗಲ್ಲ, ಸುಬ್ರಹ್ಮಣ್ಯಂ ಚಂದ್ರಶೇಖರ್ ತಂಟೆಗೆ ಹೋಗಲ್ಲ, ಪಾಪ ಒಳ್ಳೆ ಹುಡುಗರು, ನೀವು ತುಂಬಾ ಒಳ್ಳೆ ಹುಡುಗರು. So in spite of it, I would like to give you this anecdote. John Barney, physicist, got the Nobel Prize in 1958. He went to Sweden to receive his Nobel Prize from Gustav, the king. The king was surprised. He says to Barney, Mr. Barney, Nobel Prize is the highest and the most prestigious prize in the world. You are receiving it. How comes your sons are not here? Dear students, listen to me carefully what he said. What may be the reaction of Barney? You cannot imagine. You cannot dream even. He said to the king, I'll bring them next time. I repeat, when Barney was asked, you are receiving the Nobel Prize, where is your sons who haven't come for this function? Barney says, I'll bring them next time. That was the confidence Barney had. He knew that whatever research he is doing, he's continuing, will fetch him another Nobel Prize. Yes, in 1972, he gets the second Nobel Prize and goes there with the whole family. He was so happy and says, now the whole family is here. That was the confidence of John Barney. Self-confidence. That confidence comes from sincerity and hard work. What about your confidence? You take the examination. Today is the examination. In the morning, your father asks you, ಫಸ್ಟ್ ಕ್ಲಾಸ್ ಆಗಿ ಪ್ರಿಪೇರ್ ಆಗಿದ್ದೀನಿ ಅಂತೀರ. ಆಮೇಲೆ ರಿಸಲ್ಟ್ ಬರುತ್ತೆ, ಸೆಕೆಂಡ್ ಕ್ಲಾಸ್ ಬಂದ್ಬಿಟ್ಟಿರ್ತೀರ. ಏನೋ ಫಸ್ಟ್ ಕ್ಲಾಸ್ ಬರ್ತೀನಿ ಅಂತ ಹೇಳಿದ್ದೆ, ಫಸ್ಟ್ ಕ್ಲಾಸ್ ಪ್ರಿಪೇರ್ ಆಗಿದ್ದೀನಿ, ನಾನು 90% ಬರುತ್ತೆ ಅಂತ ಅನ್ಕೊಂಡಿದ್ದೆ, ನಿಂಗೆ ಬಂದಿರೋದ್ರಿ 55% ಅಂತ ಹೇಳಿದ್ರೆ ನೀವೇನ್ ಹೇಳ್ತೀರಾ? ಅಯ್ಯೋ ಒಂದೊಂದ್ಸರಿ ಆಗುತ್ತಪ್ಪ, ಹಂಗೆ ಏನ್ ಮಾಡಕ್ಕಾಗುತ್ತೆ. ಅದ್ರ ಜೊತೆಗೆ ಇನ್ನೊಂದ್ ಸೇರ್ಸರಿ, ಈ ವರ್ಷ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ಸರಿ ಇರ್ಲಿಲ್ವಂತೆ. ಸೊ ದಿಸ್ ಈಸ್ ಯುವರ್ ಕಾನ್ಫಿಡೆನ್ಸ್. ಸಿ ದ ಡಿಫರೆನ್ಸ್ between the confidence of the Nobel laureate and our confidence. Anyway, okay. So I'm a retired professor of chemistry. If I ask you the question, how many of you like chemistry? About 2 or 3% of you raise your hands. About 20% of you say, okay, sir, paravaila. Another 25%, you say, sir, whether we like it or not, we have to study. We have been compelled by our parents to study chemistry. The rest will be silent. Smashana Mauna. Why? The reason is they hesitate to say to the teacher they hate chemistry. I will ask you, why do you hate chemistry, or why you don't like chemistry? The answer that will be given by you is, sir, it requires lot of memory. We have to urufy so many things. Urufy andre urodiyadu. So many things, and it's a dry subject. Most of you say like this. My answer for this is, probably you are not taught chemistry in the right perspective. You haven't studied chemistry in the right perspective. It's not your mistake. We, the teachers, are responsible for this. I take that blame on me. I have not introduced chemistry in the proper direction. I have not made chemistry interesting for you. I'll explain this with an example. Let us say you have to study the chapter nitrogen. I'll come to your class. I will ask you, you have studied nitrogen in the 7th standard and in high school. Can anybody explain a few words about nitrogen? No answer. Matte hednala, graveyard silence. If you want to keep the students silent, ask them question. So they keep silent. Then I will start. Nitrogen. The symbol of nitrogen is N. Its formula is N2. It is present in the free state at the atmosphere to an extent of about 75%. It is present in plants and is necessary for the plants. It is present in proteins. It is present in DNA. It's present in RNA. It's available in nature as the mineral chili saltpeter, sodium nitrate, or niter, KNO3, or Indian saltpeter. Ammonium nitrate is an explosive. Gun cotton is an explosive. Dynamite is an explosive. Trinitroglycerine is an explosive. RDX is an explosive. Atomex is an explosive. All these contain nitrogen. Now, about 30% of the students start yawning. Yen boroditanale anta shuru ಮಾಡ್ತೀರ. Yes, correct. On the contrary, I've seen a Western book. There, the chapter nitrogen starts with a photograph or a picture. In the picture, Davy and his associates, Humphrey Davy, the man who found safety, who prepared safety lamp for miners. He's laughing, his associates in the room are laughing and dancing. Imagine a scientist dancing. So this is the picture. The thing is, just then, Humphrey Davy comes to know the effect of nitrous oxide called the laughing gas. In the corner of the room, he keeps an apparatus and it's added the chemical which generates slowly the laughing gas, nitrous oxide, which was pervading into the room. It was diffusing into the room. Therefore, they were laughing and dancing. Humphrey Davy says, this laughing gas increased my pulse rate by about 20 strokes and made me to dance like a madman in the laboratory. So this is the picture in the facing page of the chapter nitrogen. See the difference, how I introduced nitrogen, how that Western book introduced nitrogen. By looking at the picture, you will at least try to open the book and try to study or start studying chemistry or the chapter of nitrogen. So remember, if I ask you the question, what's the difference between candlelight and the gas light, the stove? ನಿಮ್ಮನೆ ಲೈಟ್ ಹೋದ್ರೆ ಕತ್ಲೆ ಆದ್ರೆ ಓಡೋಗಿ ಗ್ಯಾಸ್ ಸ್ಟವ್ ಹತ್ಸಲ್ಲ ನೀವು. You search for candle. What exactly the difference between the candle light and the gas light in the stove? If I ask you the question, you say, this is yellow in color, that is blue in color. That's all. But actually, what happens? See, in the candle, it's incomplete combustion. Whereas in the gas stove, it is complete combustion, almost complete combustion. Which means incomplete combustion gives light, complete combustion gives heat. That's the difference, and that is chemistry. You study the chapter alcohol. The first compound under alcohol is methyl alcohol. Second is ethyl alcohol. You know, ethyl alcohol is present in beverages. Methyl alcohol has got the molecular weight of 32. Ethyl alcohol has got the molecular weight of 46. Methyl alcohol is a smaller molecule. Ethyl alcohol is slightly a bigger molecule. So smaller molecule and kudle chikkudu kudibodu. Third molecule and kudle dottavu kudiyodu ethyl alcohol anta ankotirra. That's not so. Methyl alcohol is highly poisonous. Anybody who consumes methyl alcohol, he or she, it doesn't distinguish. Ayyo, Miss World avali papa nanu ena madabardu. Yen beautiful agidale. She is the film actor. Avali nanu affect madabardu. No. Methyl alcohol effect is same for all people. It doesn't distinguish between he or she. It's highly poisonous. It attacks the eye. He or she becomes blind by consuming methyl alcohol. That's the difference between methyl and ethyl alcohol. When you study ethyl alcohol, you should know theoretically. I repeat, theoretically, you should know what are the differences between rum, gin, sherry, champagne, wine, etc. Or even vodka. Vodka means little water. There is nothing, no harm in knowing these names theoretically and the difference between distilled and undistilled beverages. At the same time, the gas stove, the gas cylinder, if there is any gas leakage, you can know it. It is not due to the gas that is present. The butane is the main gas that is present in the gas cylinder. It's colorless and odorless. They will add what is known as methyl mercaptan, CH3SH, a thioalcohol, which has got very, very, very bad smell. So you'll know the leakage. If I ask you the question, why should that bad odored, a bad smelling compound should matter? Why not scent? Even scent can show you that there is leakage. If I ask you the question, I don't know what answer you give. The thing is, if it is a scent, you enjoy it. ನಿಮ್ಮನೆಗೆ ಯಾರಾದ್ರೂ ಬಂದಾಗ ಅಷ್ಟ ಸಿಲಿಂಡರ್ ಆನ್ ಮಾಡಿಟ್ರೆ ಮನೆಯೆಲ್ಲ ಘಮ 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 ಅಂತ ಇರುತ್ತೆ. Whereas if methyl mercaptan is present, it has got the bad smell. Immediately you go and switch off. Scent ಯಾಕೆ ಆಡ್ ಮಾಡಲ್ಲ ಅಂದ್ರೆ ಇದಕ್ಕೋಸ್ಕರ ಆಡ್ ಮಾಡಲ್ಲ. ಸೊ ಬ್ಯಾಡ್ ಸ್ಮೆಲ್ ಬೇಕು, ಓಡೋಗ್ಬೇಕು, ಈಗ ನಿಲ್ಲಿಸ್ಬೇಕು. ಅದಕ್ಕೋಸ್ಕರ so methyl mercaptan is added. So remember, without chemistry and chemicals, we cannot live for a second. Whole digestion process is a series of chemical reactions like oxidation, reduction, breaking the bond, formation of bond, etc. Suppose your body says, I don't like chemistry. Chemistry is boring. ಎಲ್ಲ ನಾವು ಕೂತ್ಕೊಂಡ್ಬಿಟ್ರೆ ಮೂಲ ಒಳಗೆ ಇಂದ ಅಷ್ಟೇ ಮುಗಿತಲ್ಲಿಗೆ ನಿಮ್ ಲೈಫ್. So body says, I'm interested in chemistry. And you say, you are not interested in chemistry. And some of you say, you hate chemistry. See, if you go to Lalbagh, if you go to Kabban Park, you see the trees. ನೀವು ಟ್ರೀಸ್ ನೋಡಲ್ಲ, ನೀವು ಇನ್ನೇನ ನೋಡ್ತೀರಾ ಪಾಪ ಹುಡುಗರು. ಪಾಪ ನಿಮ್ಗೆ ಇನ್ನೆಲ್ಲೋ ಇಂಟ್ರೆಸ್ಟ್ ಇರುತ್ತೆ. See the trees. ಲಾಲ್ಬಾಗ್ ಅಲ್ಲಿ ಹೋಗ್ಬಿಟ್ರಂತ ಪ್ರತಿಯೊಂದು ಮರಕ್ಕೂ ನೇಮ್ಸ್ ಇದೆ. ಅದು ಎಲ್ಲಿಂದ ಇದೆ, ಅದು ನೇಟಿವ್ ಯಾವುದು ಅಂತ ಇದೆ. See the flowers, the flowering season. Yellow, blue, pink, the blooming season. The color of different flowers is due to the chemicals called anthocyanins. So if you know the flowers contain that anthocyanin, you will come home and see what is anthocyanin. How exactly it will give color. ನೋಡಿ, ಚಿಕ್ಕ ಗಿಡಗಳಿದ್ದಾಗ ಅದ್ರ ಎಲೆಗಳು ಹಸಿರಾಗಿರಲ್ಲ, ಸ್ವಲ್ಪ ಪಿಂಕಿಶ್ ಅಥವಾ ರೆಡ್ ಇರುತ್ತೆ. Those leaves contain the chemical porphyrin and anthocyanins. ಈ porphyrin and anthocyanin ಇದೆಯಲ್ಲ, it will block the excess of sun rays. The tender plant ಸಿಕ್ಕಾಪಟ್ಟೆ ಸನ್ ರೇಸ್ ಬಿದ್ಬಿಟ್ರೆ ಸತ್ತೇ ಹೋಗುತ್ತದೆ, ಆಗೋದೇ ಇಲ್ಲ. ಸೊ ಅದನ್ನ ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡೋದಕ್ಕೋಸ್ಕರ ಸೊ ಇಟ್ ಹಸ್ ಗಾಟ್ anthocyanins, porphyrin, and grazing by herbivores is decreased by these chemicals. You should know, you should study chemistry through nature. You should study chemistry from your everyday life. ಆಗ ಮಾತ್ರನೇ ಇಂಟ್ರೆಸ್ಟಿಂಗ್. ಸುಮ್ಮನೆ ಕೂತ್ಕೊಂಡು ಈಕ್ವೇಷನ್ ಓದಿದ್ರೆ Mg plus 2HCl gives H to MgCl2 plus H2. Who is interested in that? I say. First, try to know chemistry of your life, the interesting facts of day-to-day life and chemistry around you. Then the class chemistry becomes very, very easy for you. Now, I'll explain one more example. You go to a shop. You want to purchase perfume or scent, rose perfume, ಹೋಗ್ತೀರಾ, ಅವನ ಅಂಗಡಿ ತೋರಿಸ್ತಾನೆ, ಬೇಕಾದಷ್ಟು ವೆರೈಟಿಗಳು, ಅದು ಇದು, ಈ ಗ್ಲಾಸು ಆ ಗ್ಲಾಸು, ಇದು ಜಾಸ್ಮಿನ್ ಸೆಂಟು, ಇದು ರೋಸು, ಇನ್ನು ಏನೇನೇನೇನೋ ಹೇಳ್ತಾನೆ. ನೀವು ಯಾವುದೋ ಒಂದು ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಬಿಟ್ಟು, ಓ ಇಟ್ಸ್ ಗುಡ್, ವಾಟ್ಸ್ ದ ಪ್ರೈಸ್ ಆಫ್ ದಿಸ್ ಅಂತ ಕೇಳಿದ್ರೆ, ಹಿ ಸೇಸ್ 500 rupees for this small bottle which consists of 100 milliliter of scent. 500 ರೂಪಾಯಿ ಇದಕ್ಕೆ ಜುಜ್ಬಿ, ಇಷ್ಟೇ ಇದೆ. ಅಂಗಡಿವನ್ ಏನಂತಾನೆ, ಸರ್ ದಿಸ್ ಇಸ್ ಜಿನಿಯನ್, ಇಟ್ ಇಸ್ ಇಂಪೋರ್ಟೆಡ್, ರೋಸ್, extracted from rose. You have studied chemistry for 5 years. When he says it is imported, you never think anything about that. You will purchase. ಸಾಕಾಗಿ ಟೋಪಿ ಹಾಕಿಸ್ಕೊಂಡ್ರಿ. ನೀವು ಓದೋ ಕೆಮಿಸ್ಟ್ರಿ ಬೇರೆ, ಲೈಫಲ್ಲಿರೋ ಕೆಮಿಸ್ಟ್ರಿ ಬೇರೆ, ಪ್ರಾಕ್ಟಿಕಲ್ಸ್ ಬೇರೆ. ಯಾಕೆ ಟೋಪಿ ಹಾಕಿಸ್ಕೊಂಡ್ರಿ? See, Genuine rose oil today costs about 80,000 rupees per kg. That depends upon the variety of rose, of course. Nearly 500 rupees for 100 milliliter. So 1 liter just 5,000 rupees. When it is available in the international market, if it costs 80,000 rupees per kg, can I give 1 kg of genuine rose oil for you for 5,000 rupees? What does it mean? Why he is giving it? It is not genuine, it is synthetic one. You know that. Or you may not be knowing that. I'm telling you now. Rose oil contains about 35 chemicals. Some of them are geraniol, linalool, nerol, citronellol, etc. All these are synthesized today. They mix it in different proportions, but we cannot imitate nature. Not possible. Certainly not possible. You want to purchase, say, silver. ಮೊದಲನೇ ಅಂಗಡಿಯವನು ಹೇಳ್ತಾನೆ, ನಮ್ಮ ಹತ್ರ ಬನ್ನಿ, you want to purchase a silverware. ಮೊದಲನೇವನು ಹೇಳ್ತಾನೆ, ನಮ್ಮ ಅಂಗಡಿ ಬನ್ನಿ, 18,000 rupees ಕೊಡ್ತೀವಿ ಅದನ್ನ. ಎರಡನೇ ಅಂಗಡಿಯವನು ಹೇಳ್ತಾನೆ, ನಾವು ಅದನ್ನ 17,000 rupees ಕೊಡ್ತೀವಿ ಅಂತ. ಥರ್ಡ್ ಅವನು ಹೇಳ್ತಾನೆ, ನಾವು 23,000 rupees ಅಂತ. ಎಲ್ಲಿ ಪರ್ಚೇಸ್ ಮಾಡ್ತೀರಾ ನೀವು? 17,000 rupees. ಕೆಮಿಸ್ಟ್ರಿ ಓದಿರ್ತೀರಾ ನೀವು? Extraction of silver from silver sulfide. Silver is converted into cyanide, cyanide is converted into sodium, argentosine. ಹೇಳಿ ಅವೆಲ್ಲ ಹೇಳ್ತೀರಾ, ಊರು ಹೊಡೆದಿರ್ತೀರಾ. ಸಾಕತ್ತಾಗೋ, ನನ್ಕಿಂತ ಚೆನ್ನಾಗಿ ಹೇಳ್ತೀರಾ ನೀವು. ನಾನೇ ಹೇಳಿದ್ರೆ ಸರ್ ಅದಲ್ಲ ಸರ್, ಇದು ಸರ್ ಮೊನ್ನೆ ಹೆಂಗ್ ಹೇಳಿದ್ವಿ ಸರ್ ಅಂತ. ಸೊ ಸೋಡಿಯಂ ಇದೆಲ್ಲ ಹೇಳ್ತೀರಾ, ಅಲ್ಲಿ ಟೊಪ್ ಹಾಕ್ಸ್ಕೊತೀರಾ. ಸೊ ಒಬ್ಬ 17, ಒಬ್ಬ 18, ಒಬ್ಬ 23, 22 ಅಂತ ಹೇಳಿದ್ರೆ ಯಾಕೆ ಅಂತ ನೀವು ಕೇಳಲ್ಲ. ಅವ್ನು ಕಮ್ಮಿ ಕೊಡ್ತಾನೆ ಅಂದ್ರೆ ಅವನು ಲಾಭ ಕಮ್ಮಿ ಇಟ್ಕೊಂಡಿದ್ದಾನೆ ಕೊಡ್ತಾನೆ, ಅಲ್ಲ. You never ask for percentage of silver there. Same percentage of silver ಇರಲ್ಲ, ಬೇರೆ ಬೇರೆ ಇರುತ್ತೆ. ನೀವು ಕೇಳೋದೇ ಇಲ್ಲ ಅದನ್ನ. Suppose I ask you, what is the unit of purity of gold? Carat. What is carat? ಗೊತ್ತಿಲ್ಲ, ನೀವು ತಿಳ್ಕೊಳ್ಳಲ್ಲ. 24 ಕ್ಯಾರೆಟ್ ಗೋಲ್ಡ್ ಅಂದ್ರೆ 24 ಕ್ಯಾರೆಟ್ ಗೋಲ್ಡ್ ಅಷ್ಟೇನೆ. ನಿಮಗೆ ಗೊತ್ತಿರೋದು ಒಂದೇ ಕ್ಯಾರೆಟ್, CARROT. ನೀವು ಕ್ಯಾರೆಟ್ ಅಂದ್ರೆ ಏನು ಅಂತ ತಿಳ್ಕೊಳ್ಳಿಕ್ ಹೋಗೋದೇ ಇಲ್ಲ. ಓಕೆ, ಸಾರಿ ಅನ್ಬಾರ್ದಲ್ವಾ, ಎಕ್ಸ್ಕ್ಯೂಸ್ ಮೀ ಅನ್ಬೇಕು. ಹೌದು, ನಮ್ಗೆ ಅವೆಲ್ಲ ಬರಲ್ಲ, ಸ್ವಲ್ಪ ಕಷ್ಟ ಈ ಇಂಗ್ಲಿಷು. ಎಕ್ಸ್ಕ್ಯೂಸ್ ಮೀ ಅಂತೀನಿ, ನೀವು ಎಕ್ಸ್ಕ್ಯೂಸ್ ಅಂತ ಹೇಳಲ್ಲ ಅದ್ರ ಬಗ್ಗೆ. ಓಕೆ, ಸಪೋಸ್ ಯು ವಾಂಟ್ ಟು ಬೈ ಸ್ಯಾಂಡಲ್ ಸೋಪ್. ಒಂದು ಅಂಗಡಿಗೆ ಹೋಗ್ತೀರಾ, ಸ್ಯಾಂಡಲ್ ಸೋಪ್ ತಗೋತೀರಾ. See, you don't know. Once Karnataka was known for sandalwood oil, excellent quality sandalwood oil. We had a research center at Shumaga, Sandalwood Oil Research Center. About 10 years back or 15 years back, we didn't have this sandalwood trees at all. Now the situation is slowly improving. So sandalwood, you purchase sandalwood soap, you never think ಸ್ಯಾಂಡಲ್ವುಡ್ ಇಲ್ಲ ಎಲ್ಲಿಂದ ಬಂತು ಅಂತ ಏನಾದ್ರು ಯೋಚನೆ ಮಾಡ್ತೀರಾ ನೀವು ಯಾವತ್ತಾದ್ರೂ ಸ್ಯಾಂಡಲ್ ಆಯಿಲ್ ಹಾಕಿದ್ದಾರೆ ಅಂದ್ರೆ? ಅವೆಲ್ಲ ನೀವು ಯೋಚನೆ ಮಾಡಕ್ ಹೋಗೋದೇ ಇಲ್ಲ, ಎಂದಿಗೂ ಯೋಚನೆ ಮಾಡಲ್ಲ. ದಿಸ್ ಈಸ್ ಕೆಮಿಸ್ಟ್ರಿ. ದಿಸ್ ಸ್ಯಾಂಡಲ್ವುಡ್, ದಿ ಪರ್ಫ್ಯೂಮ್, ದ ಸೆಂಟ್, ದ ಓಡರ್ of that is due to the presence of two compounds, santalol and santalene, which belong to the family of terpenoids. This is chemistry. Today, we know how to synthesize santalol and santalene. So, namage sandalwood oil sigade idrunume santalol, santalene mix madidre agoy. So, it is synthetic one, not the genuine sandalwood oil. There are about 20 to 25, ಇನ್ನು ಜಾಸ್ತಿ ಇತ್ತು ಮೊದಲು, about 20 or 25 brands of soap. If you go to a departmental store and see, ಹೋದಾಗೆಲ್ಲ ನೋಡ್ಬೇಕು ಒಂದ್ ಸ್ವಲ್ಪ ಎಷ್ಟು ತರ ಸೋಪ್ಗಳಿದಾವೆ. ಸರಿ, ಏನ್ ಡಿಫರೆನ್ಸ್? Do you know the difference between sandalwood soap, sandal soap? Do you know the difference between dry soap, Savlon, Lifebuoy, Rexona, or Lux, or see-through soap, Tears? You don't know the difference. ಯಾರೋ ಹೇಳ್ತಾರೆ ಪಕ್ಕದ ಮನೆ ಸ್ಯಾಂಡಲ್ ಸೋಪ್ ತಗೊಂಡ್ರು, ನೀವು ಸ್ಯಾಂಡಲ್ ಸೋಪ್ ತಗೊಂಡ್ರು. ಅಡ್ವರ್ಟೈಸ್ಮೆಂಟ್ ಅಲ್ಲಿ ಇನ್ಯಾವ್ದೋ ತೋರಿಸಿದ್ರು, ನಾನು ಅಮ್ಮನ ಹಾಗೆ ಅಂತ ಹಿಂಗಂದ್ರು, ತಗೋ ನಾಳೆ ಪಿಯರ್ಸ್. Why that Piers has got that look? See-through. It's crystallized from alcohol. Soap, the content of the soap is same, but perfumes, the additives, perfumes, lather giving substances, the compounds which give lather. Morning to Professor Nataraj. Lather, giving lather and color, or the differences between different brands of soaps. Don't you think it's interesting to know this? Don't you think so? That chemistry is interesting, it's fascinating. ನೀವು ಈಕ್ವೇಶನ್ ಕೂತ್ಕೊಂಡು ಬರೆಯೋಕ್ ಶುರು ಮಾಡಿದ್ರೆ, ಉರು ಹೊಡಿಯೋಕ್ ಶುರು ಮಾಡಿದ್ರೆ, ಕೆಮಿಸ್ಟ್ರಿ ಅಂತ ಕೆಮಿಸ್ಟ್ರಿ ಅಲ್ಲ, ಫಿಸಿಕ್ಸ್ ಬೋರು, ಮ್ಯಾಥ್ಸ್ ಬೋರು, ಎಲ್ಲವುದು ಬೋರೆ. ನಿಮ್ಮನ್ನು ಕೇಳಿದ್ರೆ ಎಲ್ಲವುದು ಬೋರು. You might have seen the advertisement. Sunflower oil, soybean oil is healthier than any other oil like coconut oil, groundnut oil, etc. So ಪಕ್ಕದ ಮನೆಯವರು ಸೋಯಾಬೀನ್ ಆಯಿಲ್ ತಗೋತಾರೆ, ನೀವು ಸೋಯಾಬೀನ್ ಆಯಿಲ್ ತಗೋ. ನಾಳೆ ಅವ್ರು ಸನ್ಫ್ಲವರ್ ಆಯಿಲ್ ತಗೊಂಡ್ರು, ನೀವು ಸನ್ಫ್ಲವರ್ ಆಯಿಲ್ ತಗೊಂಡ್ರು. ಅಥವಾ ಅವ್ರು ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಕಾಸ್ಟ್ಲಿ ತಗೊಂಡ್ರು, ಪ್ರೆಸ್ಟೀಜ್, ನೀವು ಕಾಸ್ಟ್ಲಿಗೆ ಹೋದ್ರಿ. At any time, have you thought of what is the difference between coconut oil, groundnut oil, this sunflower oil, soybean oil, etc.? No, you don't know. Even if you study chemistry for 10 years, you will not be knowing, and you are not interested in to know this. Okay, if I ask you the question, why coconut oil is solid at room temperature, you say the boiling point, sorry, the melting point of coconut oil is low. If I ask you why that coconut oil has got low boiling point compared to groundnut oil, palm oil, etc., you don't know. And you never ask such questions in the class. Sometimes you may be interested in asking such questions, but the teacher may not be knowing the answer. ನೀವು ಒಂದ್ ದಿವಸ ಕ್ವಶನ್ ಕೇಳ್ತೀರಾ, ಮೇಷ್ಟ್ರಿಗೆ ಆನ್ಸರ್ ಗೊತ್ತಿರುತ್ತೆ, ಖುಷಿಯಾಗಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾರೆ, 10 ನಿಮಿಷ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾರೆ ನಿಮ್ಗೆ. ಆಮೇಲೆ ನಿಮ್ಮನ್ನು ಕೇಳ್ತಾರೆ, ವಾಟ್ಸ್ ಯುವರ್ ನೇಮ್? ಓ KVG. ಓ I see, wonderful, wonderful. What city you have read? Oh, okay. What's your father? Oh, so very, very happy to see you. You have asked a wonderful question. ಇನ್ನೊಂದು ದಿವಸ ಇನ್ನೊಂದು ಕ್ವಶನ್ ಕೇಳ್ತೀನಿ, ಅವತ್ತು ಅವ್ರ ಆನ್ಸರ್ ಗೊತ್ತಿರಲ್ಲ. ಏನ್ ಅನ್ಕೊಂಡಿದ್ಯಾ? I've seen 10,000 people like you. You want to test me? ಅದಕ್ಕೆ you never want to ask questions. Question ಕೇಳಕ್ಕೆ ಹೋಗಲ್ಲ. ನಮ್ಮ ಸಿಸ್ಟಮ್ ಆಫ್ ಎಜುಕೇಶನ್ is such that, ಸರ್ ನೀವು ನಮ್ಮನ್ನು ಕ್ವಶನ್ ಕೇಳಬೇಡಿ, ನಾವು ನಿಮ್ಮನ್ನು ಕ್ವಶನ್ ಕೇಳಲ್ಲ. We shall live happily with mutual cooperation. ನಾವು ನಿಮ್ಮ ಮರ್ಯಾದೆ ತೆಗೆಯಲ್ಲ, ನೀವು ನಮ್ಮ ಮರ್ಯಾದೆ ತೆಗಿಬೇಡಿ. This is our system of education. See, as I said, life, the process that takes place, the chemical reactions that take place in our body, everything is chemistry, 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 chemistry. Hemoglobin of blood carries oxygen by redox reaction. Ferrous, ferric, ferrous, ferric, ferrous, ferric. Oxidation, reduction reactions. Melanin pigment gives black color to the hair. Of course, nandilla. Melanin pigment alla ಹೊರಟಾಗಿದೆ. melanocytes alla ಸತ್ತೋಗ್ಬಿಟ್ಟಿದಾವೆ. ಸೊ ಹಾಗಾಗಿ ಈ ತರ ಗ್ರೇ ಕಲರ್ ಆಗಿದೆ. See, why should you take sodium chloride? See, Na plus ion present in it is necessary for water balance in the body. If water has to flow into the cell and the waste products has to come out of the cell, water has to enter, water has to come out, etc. Proper quantity of Na plus is necessary. Suppose somebody is suffering from diarrhea, vomiting, he or she will be admitted to the hospital. Immediately saline injection ಆಗ್ತಾರೆ. ನೀವು ಯಾರಾದ್ರೂ ಹುಡುಗರು ಅಲ್ಲಿಗೆ ಹೋದಾಗ saline injection ಅಲ್ಲಿ ಏನಿರುತ್ತೆ, ವಾಟ್ ಇಸ್ ದ ಪರ್ಸೆಂಟೇಜ್ ಆಫ್ saline ಅಂತ ನೋಡಿದ್ದೀರಾ? ಇಲ್ಲ, ನೋಡಿರಲ್ಲ. ನೀವು saline injection ಪರ್ಸೆಂಟೇಜ್ ಎಷ್ಟಿರುತ್ತೆ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಅಂತ ನೋಡಿರಲ್ಲ. ಇಟ್ ಶುಡ್ ಬಿ 0.9%. ಅದಕ್ಕೆ ಎಕ್ಸ್ಪರ್ಟ್ಸೇ ಕೊಡಬೇಕು, ನಾವು ಕೊಡಕ್ಕಾಗಲ್ಲ. ನಾವು ಅವನಿಗೆ ಸೊ ಸಿಕ್ಕಾಪಟ್ಟೆ ಡಿಹೈಡ್ರೇಷನ್ ಆಗ್ಬಿಟ್ಟಿದೆ ಅಂತ ಅಂದ್ಬಿಟ್ಟು 1.5% saline ಇರೋ ಇಂಜೆಕ್ಷನ್ ಹಾಕಿದ್ರೆ, ಅಥವಾ ಕಮ್ಮಿ, ಏನ್ ಅಂತ ಡಿಹೈಡ್ರೇಷನ್ ಏನಾಗಿಲ್ಲ ಬಿಡಲೆ, ನೋಡಿದ್ರೆ ಎಷ್ಟು ಚೆನ್ನಾಗಿ ಕಾಣಿಸ್ತಾನೆ, ಮಾತಾಡ್ತಾನೆ ಇಷ್ಟು ಬರಗೆ, ಏನಾಗಿಲ್ಲ ಅವನಿಗೆ, 1.7%. If it is more than 0.9 or if it is less than 0.9, operation successful, patient died. ಅಷ್ಟೇ, ಮುಗಿದೋಯ್ತು ಅಷ್ಟೇ. It should be exactly 0.9 to maintain the osmotic pressure inside and outside the cell. Then only proper flow of Na plus. Are you not fascinated, dear students? Are you not fascinated by this chemistry? I am at this, even at this age. ಬಹಳ ಖುಷಿ ಆಗುತ್ತೆ ಇದು ನೋಡಿದ್ರೆ ನನಗೆ. Why? See, now I will ask you a question. ನನಗಿದು ಎಂಜಿನಿಯರಿಂಗ್ ಗೆ ನಮಗೂ ನಿಮ್ಗೆ ಇದ್ದಾಗೆ ನಾವ್ ಹೇಳ್ತೀವಿ ಅಭಾವ ವೈರಾಗ್ಯ ಅಂತ ನಮ್ದು. ನಿಮ್ಗೆ ಎಂಜಿನಿಯರಿಂಗ್ ಹೋಗ್ಬೇಕು ಅಂತ ಇರ್ತೇವೆ, ಎಂಜಿನಿಯರಿಂಗ್ ಯಾಕೆ ಓದ್ಬೇಕು ಅಂತೀವಿ ನಾವು. ನಿಮ್ಗೆ ಯಾಕೆ? ಈಗ ನಮ್ದು ಅಲ್ವಲ್ಲ, ನಾವು ಏಜ್ ಆಗೋಗ್ಬಿಟ್ಟಿದೆ. ಅದಕ್ಕೋಸ್ಕರ ನಾವಿದ್ದಾಗ ನಾವು ಇಂಜಿನಿಯರಿಂಗ್ ಓದ್ಬೇಕು ಅಂತ ನಿಮ್ಮಷ್ಟೇ ಆಸೆ ಇತ್ತು. ನಾನು ಇಂಜಿನಿಯರಿಂಗಿಗೆ ಹೋಗಿದ್ದೆ, ನಾನು ಇಂಟರ್ವ್ಯೂಗೆ. ಅಲ್ಲಿ ಕೇಳಿದ್ರು, ಒಂದು ಕ್ವಶನ್ ಕೇಳಿದ್ರು, ಯು ಪ್ರಿಪೇರ್ ಟೀ ಇನ್ ಬ್ಯಾಂಗ್ಳೂರ್ or coffee in Bangalore and on Mount Everest, which decoction is stronger? ನಂಗೆ ತೀರಾ ಸ್ಟ್ರಾಂಗರು ವೀಕರು ಅವೆಲ್ಲ ಗೊತ್ತಾಗ್ಲಿಲ್ಲ, ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ or diluted ಗೊತ್ತಾಗ್ಲಿಲ್ಲ. I said something about boiling point. I knew something about boiling point. Now, if I ask you the same question to you, which decoction, coffee or tea, prepared in Bangalore or on Mount Everest, will be stronger but natural? It is at Bangalore. Because if you go 1,000 feet above MSL, for every 1,000 feet, boiling point will be reduced by 1 degree Celsius. So Mount Everest, the height of Mount Everest is 29,000. Therefore, the boiling point of water is 71 degrees. If my arithmetic goes correctly, 100 minus 29 is 71. 71 degrees Celsius. So at 71 degrees Celsius, extraction of tannin or caffeine is not complete. Therefore, you get diluted one. Only you get strong decoction. Only here, the boiling point of water at Bangalore is 97 degrees Celsius, because Bangalore is at a height of 3,000 feet. The thing is, you should know the basics of any subject, and you should know how to apply that in life. Then only it will be interesting. ನಾನು ಈ ತರದ ಬೇಕಾದಷ್ಟು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ. ಈಗ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ. ಚಳಿಗಾಲ, ಡಿಸೆಂಬರ್, ಚಳಿ ಅಂದ್ರೆ ಓಹೋ ಸಿಕ್ಕಾಪಡೆ ಚಳಿ. ಯು ವಾಂಟ್ ಟು ಪರ್ಚೇಸ್ ಅ ಸ್ವೆಟರ್. ಯು ಗೋ ಟು ಎ ಶಾಪ್. ನಾವಾದ್ರೆ ಒಂದೇ ಶಾಪ್ ಹೋಗ್ತೀವಿ, ನೀವು ಹುಡುಗರು ಬೇಕಾದ ಶಾಪ್ ಹೋಗ್ತೀರಾ. ಅಲ್ಲಿ ಕೇಳ್ತೀರಾ, ಇಲ್ಲಿ ಕೇಳ್ತೀರಾ. ಟೋಪಿ ಹಾಕ್ಸ್ಕೊಳ್ಳಿಕ್ಕೆ ಏನೇನು ಬೇಕು ಅದೆಲ್ಲವನ್ನು ಮಾಡ್ತೀರಾ. ಯು ಗೋ ಟು ಎ ಶಾಪ್. He will show you different varieties of sweaters. ಆಮೇಲೆ ಯಾವುದೋ ಒಂದನ್ನ select. Two identical, almost identical in color. You select 2 sweaters. You ask him the price. He says, the first one 500 rupees, the second one 2,000 rupees. ಇದಕ್ಕೆ 500, ಅದಕ್ಕೆ 2,000. ಯಾಕೆ ಸಮಯ ಅಂತ ಕೇಳ್ತೀರಾ ಅವನಿಗೆ ಕನ್ನಡ ಬಂದ್ರೆ. ಅವನು ಹೇಳ್ತಾನೆ, ಯು ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್ ಕೆಮಿಸ್ಟ್ರಿ, ನಿಮಗ್ ಗೊತ್ತಿರಬೇಕು ಯಾಕೆ ಡಿಫರೆನ್ಸ್ ಅಂತ. ನೀವು 10 ವರ್ಷ ಕೆಮಿಸ್ಟ್ರಿ ಓದಿರಿ, ಅವ್ನ್ ಕೆಮಿಸ್ಟ್ರಿ ಓದಿಲ್ಲ. ಅವ್ನ್ ಕೇಳಿ ಇದು ಯಾವ ಬಟ್ಟೆ ಅಂತ ಕೇಳಿದ್ರೆ ಪಾಲಿಸ್ಟಾರ್ ಅಂತ. ಅವನು ನೀವು ತಿಳ್ಕೊಬೇಕು ಅದು ಪಾಲಿಯೆಸ್ಟರ್ ಅಂತ. ಪಾಲಿಸ್ಟಾರ್ ಅಲ್ಲ, ಅದು ಪಾಲಿಯೆಸ್ಟರ್ ಅಂತ. ಸೊ 10 ವರ್ಷ ಕೆಮಿಸ್ಟ್ರಿ ಓದಿರ್ತೀರಾ, ನಿಮ್ಗೆ ಸ್ವೆಟರ್ಗೆ ವೈ ದಿಸ್ ಇಸ್ it costs 2,000 and this costs only 500. The one which costs 2,000 is genuine merino wool. The sweater made up of wool, merino. Whereas the one which costs 500 is synthetic one, acrylonitrile fiber. Acrylonitrile fiber. When you wear it, you will know. ಒಂದೊಂದ್ಸಾರಿ ಸ್ಕಿನ್ ರ್ಯಾಷಸ್ ಬಂದ್ಬಿಡುತ್ತೆ, ಆರ್ಟಿಫಿಷಿಯಲ್ synthetic ones. Synthetic wool, nylon, etc. ನಿಮ್ಮನ್ನ ಬಾಲ್ ಪಾಯಿಂಟ್ ಪೆನ್ ಇಂಕ್ಗೂ ಫೌಂಟನ್ ಪೆನ್ ಇಂಕ್ಗೂ ಡಿಫರೆನ್ಸ್ ಏನು ಅಂತ ಹೇಳಿದ್ರೆ, ಒಂದು ತಿಕ್ಕಾಗಿರುತ್ತೆ, ಒಂದು ತಿನ್ನಾಗಿರುತ್ತೆ ಸರ್. ಒಂದು ಲೀಕ್ ಆಗುತ್ತೆ, ಒಂದು ಲೀಕ್ ಆಗಲ್ಲ ಸರ್ ಅಂತ ಅಷ್ಟೇ. ಇನ್ನು ಅದಕ್ಕಿಂತ ಇನ್ನು ಜಾಸ್ತಿ ಕೇಳಕ್ ಹೋದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತಿರಲ್ಲ, ನಿಮ್ಗೆ ಇಂಟ್ರೆಸ್ಟು ಇರಲ್ಲ. Similarly, ನೋಡಿ, steel and iron, each has got its own purpose, each has got its own use. For building purposes, steel must be used. You can't use iron. Cast iron cannot be used. And for machinery parts, casting, etc., you have to use cast iron. You can't interchange. ಏನಾದ್ರು ಒಂದು ದೊಡ್ಡ ಬಿಲ್ಡಿಂಗ್ ಕ್ಯಾಸ್ಟ್ ಐರನ್ ಕಟ್ಬಿಟ್ಟು ಅವ್ನ ಮೇಲ್ಗಡೆಯಿಂದ ನೆಲ ರಿಪೇರಿ ಮಾಡ್ಬೇಕು ಅಂತ 4 ಏಟ್ ಹಾಕಿದ್ರೆ ಇಡೀ ಬಿಲ್ಡಿಂಗ್ ಆ ಕಡೆ ಬಂದ್ಬಿಡುತ್ತೆ ಕ್ಯಾಸ್ಟ್ ಐರನ್ ಅಂದ್ರೆ. ಅದೇ ರಾಟ್ ಐರನ್ ಹಾಕಿದ್ರೆ ಹಿಂಗ್ ಮಾಡಿದ್ರೆ ಹಿಂಗ್ ಬೆಂಡ್ ಆಗುತ್ತೆ. ಸೊ ಯು ಕಾಂಟ್ ಯೂಸ್, ಯು ಹ್ಯಾವ್ ಟು ಯೂಸ್ ಸ್ಟೀಲ್ ಫಾರ್ ಬಿಲ್ಡಿಂಗ್. ದಟ್ಸ್ ದ ಡಿಫರೆನ್ಸ್. ದ ಕಾರ್ಬನ್ ಕಂಟೆಂಟ್ ಇನ್ ಸ್ಟೀಲ್ ಅಂಡ್ ಕ್ಯಾಸ್ಟ್ ಐರನ್, ದಟ್ ಮೇಕ್ಸ್ ದ ಡಿಫರೆನ್ಸ್ ಇನ್ ದ ಪ್ರಾಪರ್ಟೀಸ್. Now, I would like to tell you one thing. ನಿಮ್ಮನ್ನ ಕೇಳಿ ಯಾವಾಗ ಕೇಳಿದ್ರು ಯಾಕಪ್ಪ ಓದ್ತಾ ಇಲ್ಲ, ಇಂಟ್ರೆಸ್ಟ್ ಇಲ್ಲ ಸರ್, ಎಕ್ಸಾಮ್ ಕಟ್ಟಲ್ವಾ, ಕಟ್ತೀನಿ ಸರ್. ಮತ್ತೆ ಯಾಕೆ ಓದಲ್ಲ ಅಂದ್ರೆ ಟೈಮೇ ಇಲ್ಲ ಸರ್, ಐ ಡೋಂಟ್ ಹ್ಯಾವ್ ಟೈಮ್. ಟೈಮೇ ಸಿಗ್ತಾ ಇಲ್ಲ ಸರ್. ಶಿವರಾಮ್ ಕಾರಂತರಿಗೆ ಯಾರೋ ಕೇಳ್ತಾರೆ, ನೀವು ರಾತ್ರಿ ಎಷ್ಟೊತ್ತರೆಗೆ ಓದ್ತಾ ಕೂತಿರ್ತೀರಾ ಅಂತ. ನೋಡಿ, ಜ್ಞಾನಪೀಠ ಅವಾರ್ಡ್ ವಿನ್ನರ್ ಅವರು ಹೇಳ್ತಾರೆ, ಐ ವಿಲ್ ಸ್ಟಡಿ ಫ್ರಮ್ ಸನ್ರೈಸ್ ಟು ಸನ್ಸೆಟ್. ರಾತ್ರಿ ಎಲ್ಲ ಓದಲ್ಲ ನಾನು, ಆ ಟೈಮ್ ನಂಗೆ ಸಾಕು ಅಂತ. ನಿಮ್ಮನ್ ಕೇಳಿ ಅಯ್ಯೋ ರಾತ್ರಿ ಕ್ವಯಟ್ ಆಗಿರುತ್ತೆ ಸರ್, ಅವಾಗ್ಲೇ ಓದ್ಬೇಕು ಸರ್, ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇರುತ್ತೆ ಸರ್ ಅಂತೀರ ನೀವು. ಕಾರಂತರು ಅಷ್ಟು ದೊಡ್ಡ ಮನುಷ್ಯರಾದ್ರು ಹಗಲೊತ್ತು ಓದಿ. ನಿಮ್ಮನ್ನ ಕೇಳಿ ಯಾವಾಗ ಕೇಳಿ ಟೈಮ್ ಇಲ್ಲ, ಟೈಮ್ ಇಲ್ಲ, ಟೈಮ್ ಇಲ್ಲ, ಟೈಮ್ ಇಲ್ಲ ಅಂತ. ಐ ವಿಲ್ ಗಿವ್ an example. My friend, my classmate, he was a university cricket captain during his student days. Third year BSc ಇದ್ದಾಗ he was the captain of the university cricket team. Later, he became the test umpire and one-day international cricket umpire. My friend, close friend. ಆಗಿರ್ಬೋದು ಸರ್, ಅವನಿಗೆ ಇಂಟ್ರೆಸ್ಟ್ ಇತ್ತು ಆದ. That's not the fact I'm going to explain now. He did his PhD in chemistry. He was top class scientist in the Raman Research Institute. He was the head of the liquid crystal division. He had many international laurels. He was the fellow of the Indian National Science Academy. Test umpire, ODI umpire, scientist, member, he finds time to do everything. ನೀವು ಹೇಳ್ತೀರಾ ಸರ್ ಟೈಮೇ ಇಲ್ಲ ಸರ್. ಒಂದು ಇಂಗ್ಲಿಷ್ ಸೇಯಿಂಗ್ ಇದೆ, a busy man is one who finds time to do everything. ನಿಮಗೆ ಯಾಕೆ ಟೈಮ್ ಇಲ್ಲ ಅಂದ್ರೆ ನೀವು ಏನೂ ಮಾಡೋದಿಲ್ಲ, ಅದಕ್ಕೋಸ್ಕರ ನಿಮಗೆ ಟೈಮ್ ಇಲ್ಲ ಪಾಪ. See, BGL Swami, the internationally known botanist, he was a violinist. Albert Einstein was a violinist. ನೀವು ರಿಚರ್ಡ್ ಫೈನ್ಮನ್, ನಟರಾಜ್ ಅವರಾಗ್ಲೇ ನಗ್ತಾ ಇದ್ದಾರೆ, ಫೈನ್ಮನ್ ಅನ್ಕೊಡ್ಲಿ, ಅವರಿಗೆ ಡೀಟೇಲ್ಸ್ ಎಲ್ಲ ಗೊತ್ತಿರುತ್ತೆ. Nobel laureate in physics. He was a bongo player. Bongo ಮೇಲೆ he used to play on bongo in parties. Nobel laureate. ನಿಮ್ಮನ್ನು ಕೇಳಿದ್ರೆ ಟೈಮ್ ಇಲ್ಲ, ಟೈಮ್ ಇಲ್ಲ, ಟೈಮ್ ಇಲ್ಲ ಅಂತ. The ex-chairman of ISRO, Radhakrishnan, was vocal, a musician and a Kathakali dancer. ನಿಮ್ಮನ್ನು ಕೇಳಿದ್ರೆ ಟೈಮ್ ಇಲ್ಲ ಸರ್, ಟೈಮ್ ಇಲ್ಲ ಸರ್. ಅವ್ರಿಗೆಲ್ಲ ಟೈಮ್ ಇರುತ್ತೆ, ದೊಡ್ಡ ಕೆಲಸ ಮಾಡೋರಿಗೆಲ್ಲ ಟೈಮ್ ಇರುತ್ತೆ, ನಿಮಗ್ ಮಾತ್ರ ಟೈಮ್ ಇರಲ್ಲ. ಅದು ಯಾಕೆ ಟೈಮ್ ಇರಲ್ಲ ನನಗೆ ಇನ್ನೂ ಅರ್ಥವೇ ಆಗಿಲ್ಲ. ಸೆಕೆಂಡ್ PUC ಬಂದ್ ಕೂಡಲೇ ಐ ಹೇಟ್ ಇನ್ಫ್ಯಾಕ್ಟ್ PUC. ನಿಮ್ಗೆ ಏನೇನೋ ಟ್ಯಾಲೆಂಟ್ ಇರುತ್ತೆ, ಆಲ್ ದೋಸ್ ಆರ್ ಗಾನ್. ಗಿವ್ ಎ ಡೆತ್ ನೆಲ್ ಟು ದಟ್. You'll be having talent. You may be a good singer. You may be a good athlete before coming to PUC. Remember? You may be a good dancer. You may be a voracious reader. You may be a good speaker. When you come to PUC, you leave all those things. You're compelled to leave all those things. ಯಾಕೆ ಬಿಡಬೇಕು? Adjust your time. Manage your time. You can do everything. I've seen one of my students was a Bharatanatyam dancer. A first rank in BSc, first rank in MSc, doing her PhD at Nimans today. First rank, Bharatanatyam dancer. My cousin is there. My niece is there. She is a dancer. PhD from Wisconsin. Associate professor at Delaware University. She is a Bharatanatyam dancer. And you say, and she was first rank BA from Mount Carmel College. First rank. And you say you don't have time. You don't manage time. That's the problem. You may be having 60 to 70% in SSLC, but if you do well, you can get 100%. I'm sure you will get 100%. Now I'll give you one more example. ನಮ್ಮಲ್ಲೊಬ್ಬ ಲೇಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ನಾನು ಕ್ಲಾಸಲ್ಲಿ ಹೀಗೆ ಹೇಳ್ತಾ ಇರ್ತೀನಿ, ಏನೋ ತಮಾಷೆಯಾಗಿ ಅದು ಹೇಳ್ತಿರ್ತೀನಿ, ಯಾವುದೋ ಸೈಂಟಿಸ್ಟ್ ಬಗ್ಗೆ ಹೇಳ್ತಾ ಇರ್ತೀನಿ, ಕೆಲ್ಸಕ್ಕೆ ಬರ್ದೇ ಇದ್ದು ಅಂದ್ರೆ ನಿಮ್ಗೆ ಎಕ್ಸಾಮಿನೇಷನ್ಗೆ ಬೇಡದೇ ಇರೋದು, ನೀವ್ ಹೇಳೋದು ಅದೆಲ್ಲ ಕೆಲ್ಸಕ್ಕೆ ಬರ್ದಿರ್ತಾನೆ. ಅದನ್ನೆಲ್ಲ ಸೇರಿಸ್ಬಿಟ್ಟು ಒಂದು ಪುಸ್ತಕ, ನಾನು ಏನೇನು ಕ್ಲಾಸಲ್ಲಿ ಹೇಳಿದ್ದೆ ಕೆಮಿಸ್ಟ್ರಿ ಬಿಟ್ಬಿಟ್ಟು ಅದನ್ನೆಲ್ಲ ಸೇರಿಸಿ ಒಂದು ಪುಸ್ತಕ ಮಾಡಿ ನಂಗೆ ಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ದಾರೆ. ಥ್ರೂ ಔಟ್ ದಿ ಇಯರ್ ಕೈಲಾಸಂ ಬಗ್ಗೆ ಹೇಳಿದೀನಿ, ರಾಜರತ್ನ ಬಗ್ಗೆ ಎಲ್ಲ ಇದೆ ಅದರೊಳಗೆ, ಸೈಂಟಿಸ್ಟ್ ಬಗ್ಗೆ ಇದೆ, ಆಲ್ಮೋಸ್ಟ್ 80 pages. ಅದಕ್ಕೆ ಕಲರ್ ಪೈಂಟ್ ಹಾಕಿ ಇದು ಹಾಕಿ ಎಲ್ಲ ಮಾಡಿ ನನಗೆ ಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ದಾರೆ. ಹಾಗಾದ್ರೆ ಅವ್ರ ಕ್ಲಾಸಲ್ಲಿ ಓದ್ ಕೇಳಿಸ್ಕೊತಾ ಇರಲಿಲ್ಲ ಸರ್ ಅಂತ ನೀವು ಕೇಳ್ಬೋದು. Was she not attentive in the class? ಅಂತ she got 100 out of 100 in chemistry. ಅಷ್ಟೇ, she was almost a university badminton player. ಕ್ಲಾಸಲ್ಲಿ ನಾನು ಏನೇನ್ ಜೋಕ್ ಹೇಳಿದೆ, ಯಾವ ಸೈಂಟಿಸ್ಟ್ ಬಗ್ಗೆ ಹೇಳಿದೆ ಎಲ್ಲ ಒಂದ್ ಪುಸ್ತಕ ಮಾಡಿ ನನಗೆ ನಾತ್ರ ಇದೆ, ಈಗಲೂ ಇದೆ ಪುಸ್ತಕ. So you say you don't have time. So this is the problem. Okay, coming back. ನೀವು PUC ಬರೋ ಹೊತ್ತಿಗೆ ಏನ್ ಮಾಡ್ಬೇಕು? ವಾಟ್ ಈಸ್ ವೇಲೆನ್ಸಿ? 7ನೇ ಕ್ಲಾಸಲ್ಲಿ ಓದಿದ್ವಿ ಇದು. What's the cation? What's an anion? How do they combine? How to write equation? How to balance it? Simple method. You revise this. ನೀವು 7ನೇ ಕ್ಲಾಸಲ್ಲಿ ಇನ್ನು ಓದೋದಕ್ಕೆ 3 ತಿಂಗಳು ತಗೊಂಡಿರ್ತೀರಾ. SSLCಯಲ್ಲಿ 4 ತಿಂಗಳು ತಗೊಂಡಿರ್ತೀರಾ, ಜಾಸ್ತಿ ಇರುತ್ತೆ ಸ್ವಲ್ಪ. ಇವಾಗ ರಿವೈಸ್ ಮಾಡಿ 3 ದಿವಸದಲ್ಲಿ ರಿವೈಸ್ ಮಾಡ್ಬೋದು. ಇವಾಗ ಅನ್ಕೋತೀರ ನೀವು, ಅಯ್ಯೋ SSLC ಅಷ್ಟೊಂದು ಯಾಕೆ ಕಷ್ಟಪಡ್ತೀನಿ ನಾನು, ಉರು ಎಲ್ಲ ಹೊಡೆದ್ಬಿಟ್ಟಲ್ಲಪ್ಪ, ಅಯ್ಯೋ ವೇಸ್ಟ್ ಮಾಡಿದೆ ಟೈಮ್ ಅಂತ ಈಗ ಅನ್ಸುತ್ತೆ ನಿಮ್ಗೆ. You go back, take those textbooks, revise in 2 or 3 days. This valency, formula, cations, anions, etc. Then the introducing of chemistry in first PUC becomes easy for us, and for you it becomes easy to learn. ನಾನು ಹೇಳೋ ಹೊತ್ತಿಗಾಗ್ಲೇನೆ ಇದು ಅಂತ ನಿಮ್ಗೇನೆ ಅನ್ಸೋದಕ್ಕೆ ಶುರುವಾಗುತ್ತೆ. ಹಾಗೆ ಅನ್ಸೋಕ್ ಶುರುವಾದಾಗ ಇಂಟ್ರೆಸ್ಟ್ ಬರುತ್ತೆ. ಆಮೇಲೆ ನೀವು ಮನೆಯಿಂದ ಕಾಲೇಜ್ಗೆ ಹೋಗೋ ಹೊತ್ತಿಗೆ ಎಷ್ಟೋ ಸಾರಿ ನಡ್ಕೊಂಡು ಹೋಗ್ತಾರ, ಸೈಕಲ್ ಹೋಗ್ತಾರ, ನಿಮ್ ಫ್ರೆಂಡ್ ಜೊತೆಗೆ ಕೆಮಿಸ್ಟ್ರಿನೋ ಫಿಸಿಕ್ಸ್ ಒಂದು ಚಾಪ್ಟರ್ ಸುಮ್ಮನೆ ಯಾವ್ದು ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಇರುತ್ತೆ ಅದನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡ್ಕೊಂಡು ಹೋಗಿ. ಇಲ್ಲಿ ಮನೆಯಿಂದ ಕಾಲೇಜ್ಗೆ ಹೋಗೋದ್ರೊಳಗೆ ಒಂದು ಚಾಪ್ಟರ್ ಮುಗ್ದೇ ಹೋಗ್ಬಿಟ್ಟಿರುತ್ತೆ. ಮನೆಗೆ ಬಂದು ಓದ್ಬೇಕಾಗಿದ್ದಿಲ್ಲ, ತಿರ್ಗಾ ಓದ್ಬೇಕಾದಿಲ್ಲ, ಇನ್ನು ಜಾಸ್ತಿನೇ ಗೊತ್ತಿರುತ್ತೆ ನಿಮಗೆ. You'll be ready for the examination at any time. So chemistry is as fascinating as any other subject. Nodi, you know that copper is a better conductor than aluminum. If I ask you the question, why aluminum is used for electrical transmission outside the house? Anta kelidre, most of you do not know the answer. ಯಾಕೆ? ನಾವು ಅಲ್ಯೂಮಿನಿಯಂ ಬಗ್ಗೆ ಆಗ್ಲಿ ಕಾಪರ್ ಬಗ್ಗೆ ಆಗ್ಲಿ ಏನ್ ತಿಳ್ಕೊಳಕ್ ಟ್ರೈ ಮಾಡಿರಲ್ಲ ನಾವು. ಅದಕ್ಕೋಸ್ಕರ ಅಷ್ಟೇ ಮನೆ ಒಳಗೆಲ್ಲ ಇನ್ಸೈಡ್ ದ ಹೌಸ್ ಎಂಬೆಡೆಡ್ ಒನ್ ಕಾಪರ್ ವೈರ್. ಲೆಟ್ ಅಸ್ ಸೇ ಯು ಆರ್ ಸ್ಟಿಂಕಿಂಗ್ಲಿ ರಿಚ್. ಸಿಕ್ಕಾಪಟ್ಟೆ ದುಡ್ಡಿದೆ ನಿಮ್ಮ ಹತ್ರ. Do you use, see, silver is a better conductor than copper. I think Nataraj, I'm right. Silver is about 2.9 times a better conductor than copper. But do you use, you are stinkingly rich, do you use silver or gold wires inside the house? ಬೇಜಾನ್ ದುಡ್ಡಿದೆ ಹಾಕೋಣಲ್ಲೇ ಅಂತ ಹಾಕೋತೀರಾ? ಇಲ್ಲ, ಹಾಕೊಳ್ಳಲ್ಲ. ಯಾಕೆ ಹಾಕೊಳ್ಳಲ್ಲ? ಇದು ಕೆಮಿಸ್ಟ್ರಿ ಪ್ಲಸ್ ಫಿಸಿಕ್ಸ್. ನಟರಾಜ್ ನೋಡ್ತಾನೆ ಇದ್ದಾರೆ, ಫಿಸಿಕ್ಸ್ ಹೇಳ್ತಾರೋ ಇಲ್ವೋ ಎಲ್ಲ ಹೇಳ್ತೀನಿ. This is physics, this is chemistry. Then only you will find that the class chemistry is more interesting and easy. Now, one more thing I would like to tell you. From SSLC to PUC, the standard increase, sudden increase in the standard. ಇವಾಗ ಸ್ವಲ್ಪ ಕಮ್ಮಿ ಆಗಿದೆ. NCERT ಸಿಲೆಬಸ್ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದ್ಮೇಲೆ ಗ್ಯಾಪ್ ಹ್ಯಾಸ್ ಬಿನ್ ಡಿಕ್ರೀಸ್ಡ್. ಆ PUC ಬಂದ ಕೂಡಲೇ ಸೆಕೆಂಡ್ PUC ಕೆಮಿಸ್ಟ್ರಿ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನೋಡಿದ ಕೂಡಲೇ ನೀವು ಅಯ್ಯಪ್ಪ ಸರ್ ಇಷ್ಟೊಂದು ಓದ್ಬೇಕಾ ಸರ್? ನಾನು ಹೇಳ್ತೀನಿ ನಥಿಂಗ್ ಈಸ್ ಕಂಪಲ್ಸರಿ. ಎಕ್ಸಾಮ್ ತಗೋಬೇಕು ಅಂದ್ರೆ ಓದ್ಬೇಕಷ್ಟೇನೆ. ನಥಿಂಗ್ ಈಸ್ ಕಂಪಲ್ಸರಿ. ಯಾವ್ದು ಕಂಪಲ್ಸರಿ? ಯಾವುದು ಕಂಪಲ್ಸರಿ ಇಲ್ಲ. ಸೊ ಅದು ನೋಡಿ ನೀವು ಹೆದರ್ಕೊಂಡ್ಬಿಡ್ತೀರ. ಬಟ್ if you know the basics or the fundamentals of chemistry, whole textbook becomes easy. See, you study benzene, its structure. You study methane, you study butane. Why benzene is not used as a fuel? We use natural gas methane as a fuel, butane in the gas cylinder as fuel, petrol, octane as a fuel, kerosene, decane as a fuel, tetradecane, diesel as a fuel. As the molecular weight increases, density increases, it becomes thicker and thicker. If you come to C20, it becomes a solid wax. Why can't you use benzene as a fuel? ನೀವು ಬೆಂಜಿನ್ ಇಟ್ಬಿಟ್ಟು ಅದಕ್ಕೆ ಬೆಂಕಿ ಹಚ್ಚಿದ್ರೆ ಹೊಗೆ ಬರುತ್ತೆ. ಲಾಟ್ ಆಫ್ ಕಾರ್ಬನ್, ಇನ್ಕಂಪ್ಲೀಟ್ ಕಂಬಷನ್. The burning of a fuel, if it has to burn with a blue flame, its calorific value should be high. Hydrogen to carbon ratio should be very high. Remember, simple. Hydrogen to carbon ratio. ನಿಮ್ಗೆ ಕೊಟ್ರೆ ಯಾವುದು ಮೀಥೇನ್, ಈಥೇನ್, ಪ್ಯೂಟೇನ್ ಎಲ್ಲ ವರ್ಕೌಟ್ ಮಾಡಿದಾಗ ಸರ್ ಯು ಹ್ಯಾವನ್ಟ್ ಗಿವನ್ ದಿ ವ್ಯಾಲ್ಯೂ ಫಾರ್ heat that has been liberated. Delta H value is not given. How can we say? See, remember, hydrogen to carbon ratio is fundamental. If the hydrogen to carbon ratio is on increasing, it gives more and more heat. The calorific value will be higher and higher. Very, very simple to remember. ಆಮೇಲೆ ಇನ್ನೂ ಒಂದು, ಏನಾದ್ರು ಓದೋ ಹೊತ್ತಿಗೆ ಕೆಮಿಸ್ಟ್ರಿ ಅಯ್ಯೋ ಇದನ್ನು ಓದ್ಬೇಕಲ್ಲ. See, whatever you do, you enjoy. ಕೆಮಿಸ್ಟ್ರಿ ಓದ್ಬೇಕು, ಎಸ್ ಫೈನ್, ವಂಡರ್ಫುಲ್. ಫಿಸಿಕ್ಸ್ ಓದ್ಬೇಕು, ಎಸ್ ವಂಡರ್ಫುಲ್. First of all, do not by heart anything. Do not urufy anything. ಅಲ್ಲೇ ಶುರುವಾಗದು. ನೀವು ಯಾವಾಗ ಬೈ ಹಾರ್ಟ್ ಮಾಡಕ್ ಶುರು ಮಾಡ್ತೀರೋ ಅವತ್ತಿಂದ ನಿಮ್ಗೆ ಅರ್ಥವಾಗದು. ನಾನು ಇಷ್ಟೆಲ್ಲ ಹೇಳ್ತೀನಿ, ನಾನ್ ಮಾಡಿದ್ದು ಅದೇ ಕೆಲಸ ಸ್ಟೂಡೆಂಟ್ ಡೇಸ್ ಅಲ್ಲಿ. ಬಿಟ್ಬಿಡಿ, ಇದು ಹೇಳಿದ್ನಲ್ಲ ಎಂತದೋ ಹೇಳ್ತಾರೆ ಗಾದೆ, ಬೇಡ ಬಿಡಿ. ಸೊ ಇವಾಗ ನಾವು ನಿಮ್ಗೆ ಹೇಳಕ್ಕೆ ನಮ್ಗೆ ಅಧಿಕಾರ ಇದೆ, ಮೇಷ್ಟ್ರು ನೋಡಿ ಹೇಳ್ಕೋಬಹುದು. ಸೊ ಆ ಊರು ಹೊಡೆಯೋದನ್ನ ಆದಷ್ಟು ಬಿಟ್ಬಿಡಿ. First PUC, second PUC. If you understand it properly, CET, you will get a minimum of 50 out of 60. Certainly. ಏನು ಅನುಮಾನವೇ ಇಟ್ಕೋಬೇಡಿ. ಫಸ್ಟ್ PUC, ಸೆಕೆಂಡ್ PUC. ನೀವು ಇಲ್ಲ ಸರ್ CUTಗೆ ಟ್ಯೂಷನ್ಗೆ ಹೋಗ್ಬೇಕಂದ್ರೆ ಸರ್ ಅಲ್ಲಿ ಹಾಗೆ ಮಾಡ್ತಾರಂತೆ ಸರ್, ಇಲ್ಲಿ ಹೀಗೆ ಮಾಡ್ತಾರೆ ಸರ್, ಅಲ್ಲಿರೋರ್ಗೆಲ್ಲ 60ಕ್ಕೆ 50, 55 ಎಲ್ಲ ಬರುತ್ತಂತೆ ಸರ್. ನೀವು ಒರಿಜಿನಲ್ ಆಗಿ ನಂಗೆ ಬುದ್ಧಿನೇ ಇಲ್ಲ, ನಾನಲ್ಲ 60 ತಗೊಳ್ಳಿಕ್ಕೆ. ನನಗೆ ಐ ಶುಡ್ ನೋ ಕೆಮಿಸ್ಟ್ರಿ ಫಸ್ಟ್. I should know how to apply the things, working out problems. ಯಾರು ಯಾರನ್ನು ಚೇಂಜ್ ಮಾಡಕ್ ಅಷ್ಟಲ್ಲ ಈಸಿಯಾಗಿ ಮಾಡಕ್ ಆಗಲ್ಲ. One of my students is an associate professor at IIT. Infosys founder, ಈಗ ಒಂದು 7-8 ವರ್ಷದಿಂದ the level of IITs have come down after these tutorials have started ಅಂತ ಹೇಳಿದ್ರು. ಅದಕ್ಕೆ ಏನು ಎಲ್ಲಾ ಕಡೆಯಿಂದಾನು ಅಪೋಸಿಷನ್. ಓಹೋ ಏನು ಎಲ್ಲ ಅವ್ರನ್ನ ಕಂಡಮ್ ಮಾಡಿದ್ದು. ಹಾಗೆಲ್ಲ ಏನೋ ಇಲ್ಲ ಸರ್, ಅದಿಲ್ಲ ಸರ್, ಇದಿಲ್ಲ ಸರ್ ಅಂತ ಹೇಳಿದ್ದೆ. my student is, as I said, associate professor at one of the IITs. ಅವ್ರು ಬಂದಾಗ ಹೀಗೆ ಮಾತಾಡ್ತಾ ಇದ್ದಾಗ ಹೇಳ್ತೀನಿ, so I'm surprised how these some of the students have passed second PUC ಅಂತ. ವೆರಿ ವೆರಿ ಫಂಡಮೆಂಟಲ್ಸ್, ಒಂದು ಅಪ್ಲಿಕೇಶನ್ ಇರೋದು. ಇನ್ ಕೊಟ್ಟಿದ್ದೀನಪ್ಪ, ಇದ್ ಏನ್ ಮಾಡ್ತೀಯಪ್ಪ ಅಂತ ಕೇಳಿದ್ರೆ ಕಂಡು ಬಿಡ್ತಾನೆ ಸರ್ ಅವನು. ಈ ತರದವ್ರು ವರ್ಷ 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 ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದ್ದಾರೆ. ನಾವು IIT ಅಂದ್ರೆ ಎಲ್ಲ ಪ್ರಬುದ್ಧಿಗಳು ಪ್ರಸ್ಪತಿಗಳು ಅಂತ ಅನ್ಕೊಂಡಿರ್ತೀವಿ. ಅವ್ನು ಕೇಳಿ ಅದೇ PUC ಹೆಂಗ್ ಪಾಸ್ ಮಾಡೋದು ನಂಗೆ ಗೊತ್ತಿಲ್ಲ ಸರ್ ಅಂತ. ಈಸ್ ಅನ್ ಅಸೋಸಿಯೇಟ್ ಪ್ರೊಫೆಸರ್. ಸೊ ಹೀಗೆ ನೀವು ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆ ಇನ್ನೂ ಒಂದು ಹೇಳ್ತೀನಿ, ನೋಟ್ಸ್ ಓದಿ ಫಸ್ಟ್, ಒಂದ್ ಸ್ವಲ್ಪ ಅರ್ಥ ಆಗುತ್ತೆ. ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಓದಿ, ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಅರ್ಥ ಆಗುತ್ತೆ. ಇನ್ನೊಂದ್ 2-3 ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಓದಿ, ಇನ್ನೂ ಜಾಸ್ತಿ ಅರ್ಥವಾಗುತ್ತೆ. ಅದರಲ್ಲಿ ಯಾವ್ಯಾವ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಏನೇನ್ ಸ್ಪೆಷಾಲಿಟೀಸ್ ಇದೆ, ಅದರಲ್ಲಿ ಎಕ್ಸ್ಟ್ರಾ ಏನಿದೆ, ಒಂದು ನೋಟ್ಸ್ ಮಾಡ್ಕೊಳ್ಳಿ. ನಾನು 52ನೇ ವರ್ಷ ಟೀಚ್ ಮಾಡ್ತಾ ಇರೋದು. ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ 3 ದಿವಸದಿಂದ ಕೂತ್ಕೊಂಡು ಪ್ರಿಪೇರ್ ಆಗಿದ್ದೀನಿ. ಇಷ್ಟು ಪ್ರಿಪೇರ್ ಆಗಿದ್ದೀನಿ ಇದ್ ಮಾಡೋದಿಕ್ಕೆ ಅಂತ ಹೇಳಿ, ಇಷ್ಟು ಪ್ರಿಪೇರ್ ಆಗಿದ್ದೀನಿ. ನಾನು ಎಷ್ಟು ಪ್ರಿಪೇರ್ ಆಗ್ತೀನಿ ಅಂದ್ರೆ ನೀವು ಅಷ್ಟೇ ಪ್ರಿಪೇರ್ ಆಗ್ಬೇಕು. ಕೂತ್ಕೊಂಡು ಓದ್ಬೇಕು, ಓದಿ ಇರೋದನ್ನ ಹೇಳ್ಬೇಕು. Alpha, it is 1 hour exactly now. I started at 10:22.
Yeah.
Is it okay? So students, last 2 sentence. ನಾನು ಇಷ್ಟೆಲ್ಲ ಹೇಳಿದ ಮೇಲೆ ಕೆಮಿಸ್ಟ್ರಿ ಓದಬೇಕು ಅಂತ ಅನ್ಸಿದ್ರೆ, ಇವ್ರು ಕೊಟ್ಟಿರೋ ಟೈಟಲ್ ಲವ್ ಫಾರ್ ಕೆಮಿಸ್ಟ್ರಿ ಸರಿಯಾಗಿದೆ ಅಂತ ನನಗನ್ಸುತ್ತೆ. ಅದ್ರ ಜೊತೆಗೆ ನಾನು ಏನೋ ಒಂದಷ್ಟು ಹೇಳಿದ್ದೀನಿ ನಿಮಗೆ ಅಂತ ಅನ್ಸುತ್ತೆ. ಎನಿವೆ, ನಾನಿನ್ನ ಹೇಳಿದ್ದನ್ನ ತಗೊಂಡು ಕೆಮಿಸ್ಟ್ರಿ ಏನಾದ್ರು ಒಂದ್ ಸ್ವಲ್ಪ ಇಂಟ್ರೆಸ್ಟ್ ಬಂದಿದ್ರೆ, ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್. ಥ್ಯಾಂಕ್ಸ್ ಫಾರ್ Professor Nataraj, Altaf, PV Jagdish Science Center. Thank you very much. More than that, I would like to thank Dr. H.S. Raghavendra Rao. He's there listening to me. Okay, right off.
Yeah. Thank you so much, sir. I think we can take a few questions if there are any. ಯಾರಾದ್ರೂ ಪ್ರಶ್ನೆ ಕೇಳಬೇಕು ಅಂತ ಇದ್ರೆ ಕೇಳಿ.
ಕೇಳಬಹುದು. ಕ್ವಶನ್ ಕೇಳೋದು ಕಂಪಲ್ಸರಿ, ಆನ್ಸರ್ ಹೇಳೋದು ಕಂಪಲ್ಸರಿ ಇಲ್ಲ. ಕ್ವಶನ್ ಕೇಳಬಹುದು, ಯಾರು ಬೇಕಾದ್ರೂ ಕೇಳಬಹುದು. ಕೇಳಿ.
ಕ್ವಶನ್ ಕೇಳಂಗಿದ್ರೆ ಕೇಳ್ಬೋದು, ಕೇಳ್ತೀನಿ.
ಗೊತ್ತಿದ್ರೆ ಹೇಳ್ತೀನಿ, ಇಲ್ಲೇ ನೋಡ್ಬಿಟ್ಟು ಹೇಳ್ತೀನಿ. ಇದು ಹೇಳ್ದ ವಿತ್ ಮ್ಯೂಚುವಲ್ ಕೋಆಪರೇಷನ್ ಅಂತ ಕ್ವಶನ್ ಕೇಳಲ್ಲ.
ಸರ್ ಒಂದ್ ಕ್ವಶನ್ ಸರ್.
ಹಾ, ಒಂದೇನಾ
ಸರ್? ಅದು ಒಂದ್ರಲ್ಲೇ ನಿಮ್ಗೆ ಕೇಳ್ತೀನಿ ಸರ್.
ಹಾ
ಸರ್, ಏನು ಅಂದ್ರೆ ನೀವು ಕೆಮಿಸ್ಟ್ರಿ ನಮ್ಮ ಡೇ ಟು ಡೇ ಲೈಫ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರಲ್ಲ ಸರ್. ಕೆಮಿಸ್ಟ್ರಿ ಅಂದ್ರೇನೆ ನಮ್ ಡೇ ಟು ಡೇ ಲೈಫ್. ನಾವು ಅಡಿಗೆ ಮಾಡೋದಿರ್ಬೋದು, ಎಲ್ಲ ಪ್ರತಿಯೊಂದು ಇದ್ರಲ್ಲೂ ಕೆಮಿಸ್ಟ್ರಿ ಇದೆ ಅಂತ ನೀವು ಹೇಳ್ತೀರಾ ಅಲ್ವಾ ಸರ್?
ಹೌದು
ಸರ್, ಹಾಗಿದ್ರೆ ಕೆಮಿಸ್ಟ್ರಿ ಬೋರ್ ಯಾಕೆ ಸರ್?
ಯಾಕೆಂದ್ರೆ ನಾನು ಮೊದಲೇ ಹೇಳ್ಬಿಟ್ಟೆ ನಿಮಗೆ, ನಾವು ಟೀಚ್ ಮಾಡ್ತೀವಲ್ಲ, ಮೆಥಡ್ ಸರಿ ಇಲ್ಲ. ನಿಮ್ದೆಲ್ಲ ಮಿಸ್ಟೇಕ್, ಅದು ನನ್ನ ಮಿಸ್ಟೇಕ್. ಐ ಹ್ಯಾವ್ ನಾಟ್ ಮೇಡ್ ಕೆಮಿಸ್ಟ್ರಿ ಇಂಟ್ರೆಸ್ಟಿಂಗ್. ಸಿ, ನೀವು ಎಗ್ ಅನ್ನು ಬಾಯ್ಲ್ ಮಾಡಿದ್ರೆ ಸಾಲಿಡ್ ಆಗುತ್ತೆ. ದ ಪ್ರೋಟೀನ್ ದಟ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್, ಆಲ್ಬುಮಿನ್ಸ್, ಗ್ಲೋಬ್ಯುಲಿನ್ಸ್, ದೇ ಅಂಡರ್ಗೋ precipitation, they undergo coagulation. It's an irreversible process. Sometimes it is irreversible. ನೋಡಿ, ಗಟ್ಟಿ ಆದ್ಮೇಲೆ ಮತ್ತೆ ಅದರಿಂದ ಎಗ್ ಯೋಕ್ ಬರಲ್ಲ. ಬೈ ಚಾನ್ಸ್ ನಿಮಗೆ ಎಗ್ ಯೋಕ್ ಬೇಕು ಅಂದ್ರೆ ಆ ಮೊಟ್ಟೆನ ಮತ್ತೆ ಕೋಳಿ ತಿನ್ಸಿದ್ರೆ ನಾಳೆ ಬೆಳಿಗ್ಗೆ ಬರುತ್ತೆ ಅಷ್ಟೇ. ಅರ್ಥವಾಯ್ತಲ್ವಾ? ಸೊ ಇದು ಕೆಮಿಸ್ಟ್ರಿ. ಬ್ಲಡ್ ಎಲ್ಲೋ ಊಸ್ ಔಟ್ ಆಗ್ತಾ ಇದೆ, ಎಲ್ಲೋ ಗಾಯ ಆಯ್ತು, ಊಸ್ ಔಟ್ ಆಗ್ತಾ ಇದೆ, ಇದು ಫೆರಿಕ್ಲೋರೈಡ್ ಹಾಕಿ. Clotting of blood takes place. That ferric ion is the clotting agent there. So every day ಹೀಗೆ ನಿಮಗೆ ಎಲ್ಲವೂ ಡೇ ಟು ಡೇ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹೇಳೋ ಹೊತ್ತಿಗೆ ದಿವಸ ಒಂದು 5-10 ನಿಮಿಷ ಕ್ಲಾಸ್ ಬಿಟ್ಟು ಬೇರೆದನ್ನ ಹೇಳ್ಬೇಕು. There are so many people who scientists, chemistry people who have died for chemistry. You should remember them. Yes. ಹೇಳಿ, ಇನ್ನು ಅದ ಕಂಟಿನ್ಯೂಷನ್ ಇದೆಯಾ ಕ್ವಶನ್?
ಸರ್ ಇಲ್ಲ ಸರ್. ಅದು ಒಂದೇ ಕ್ವಶನ್ ಅಂದ್ರೆ ನೀವು ಕೆಮಿಸ್ಟ್ರಿ ಫಸ್ಟ್ ಬೋರ್ ಅಂದ್ರಲ್ಲ, ಕ್ವಶನ್ ಕೇಳೋಣ ಅಂತ ನಾಪ್ಕ ಇಟ್ಕೊಂಡಿದ್ದೆ.
ಅದೇ ಕೆಮಿಸ್ಟ್ರಿ ನನಗೂ ಹಾಗೆ ಅನ್ನಿಸ್ತಿತ್ತು ಒಂದ್ ಕಾಲದಲ್ಲಿ. ಸರಿಯಾಗಿ ಓದೋವರೆಗೂ ಸರಿಯಾಗಿ ಓದಕ್ ಶುರು ಮಾಡಿದ್ಮೇಲೆ ಇದಾಯ್ತು. ಕೆಮಿಸ್ಟ್ರಿ is as fascinating as any other subject and far more fascinating. Yes. Any other question? Fortunately ಅವ್ರು ಕೇಳಿದ್ದಕ್ಕೆ ನಂಗೆ ಆನ್ಸರ್ ಗೊತ್ತಿತ್ತು. ಅದೇ ತರದ ಕ್ವಶನ್ ಕೇಳಿ.
ಇನ್ನು 4 ನಿಮಿಷ ಇದೆ, ಇನ್ನೊಂದು ಕ್ವಶನ್ ತಗೋಬಹುದು.
ಹೇರ್ ಡೈ ಸುಮ್ಮನೆ ನೋಡಿ, ನಾನು ಹೇರ್ ಡೈ ಮಾಡಿಲ್ಲ ಬಿಕಾಸ್ ಐ ಆಮ್ ಎ ಕೆಮಿಸ್ಟ್ರಿ ಮ್ಯಾನ್. ಐ ನೋ ಹೇರ್ ಡೈಸ್ ಅನ್ಲೀನ್ ಅಂಡ್ ದೇರ್ ಡೆರಿವೇಟಿವ್ಸ್, ಮೆಟಾಫಿನ್ಲಿನ್ ಡೈಅಮೈನ್ ಅಂಡ್ ದೇರ್ ಡೆರಿವೇಟಿವ್ಸ್ ದೇ ಕಾಸ್ ಕ್ಯಾನ್ಸರ್. ನೀವು 20 ದಿವಸಕ್ಕೆ ಒಂದ್ಸರಿ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ರೆ ಇನ್ 1 year about 4 milligram of the dye will enter through the scalp one day or the other. ಯಾವತ್ತೋ ಒಂದ್ ದಿವಸ ಕ್ಯಾನ್ಸರ್ ಆಗುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ ಈ ತರದೆಲ್ಲ ಆರ್ಟಿಫಿಷಿಯಲ್ ಇದು ಇದೇ ಇರುತ್ತೆ. DDT, the man who showed DDT as an insecticide got Nobel Prize. Today DDT is banned. ಸೊ ಮಾರಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಹೇಗೆ ಚೇಂಜ್ ಆಗುತ್ತೋ, ಎಥಿಕಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಹೇಗೆ ಚೇಂಜ್ ಆಗುತ್ತೋ, ಕೆಮಿಕಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಹಾಗೆ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಕೆಮಿಸ್ಟ್ರಿ ಅದು ಓದ್ತಾ ಇದ್ರೆ ಅದು ಫ್ಯಾಸಿನೇಟಿಂಗ್, ತಿಳಿತಾ ಇದ್ರೆ ಫ್ಯಾಸಿನೇಟಿಂಗ್, ದಿವಸ ಇದಿದ್ರೆ ಫ್ಯಾಸಿನೇಟಿಂಗ್. ಎಸ್ ಎನಿಬಡಿ? ಅಥವಾ ಎನಿ ಬಾಡೋ? ಬಾಡಿ ಅಂದ್ರೆ ಇಕಾರ ಅಂತ ಸ್ತ್ರೀಲಿಂಗ, ಬರೀ ಎನಿ ಬಾಡೋ? ಈಗ ಹೇಳಿದ್ ಎನಿ ಬಾಡೋನೆ. ಎನಿಬಡಿ?
ಐ ಥಿಂಕ್ ನಟರಾಜ್ ಸರ್ ಕ್ಲೋಸಿಂಗ್ ವರ್ಡ್ಸ್ ಹೇಳ್ಬಹುದು.
ಕೇಳಿಸ್ತಾ ಇದೆಯಾ?
ಎಸ್ ಸರ್, ಕೇಳಿಸ್ತಾ ಇದೆ.
ಮೊದಲನೇದಾಗಿ ನಾನು ಐ ವುಡ್ ಲೈಕ್ ಟು ಥ್ಯಾಂಕ್ ಪ್ರೊಫೆಸರ್ ಕೆ.ವಿ. ಘನಶ್ಯಾಮ್ ಫಾರ್ ಹಿಸ್ ಇನ್ಸ್ಪೈರಿಂಗ್ ಟಾಕ್. ಅವರು ಮೊದಲಿಂದಲೂ ಹಾಗೆ ತುಂಬಾ ಕ್ಯಾಶುವಲ್ ಆಗಿ ಮಾತಾಡೋದು ಅಭ್ಯಾಸ. ಅವ್ರಿಗೆ ತುಂಬಾ ಕ್ಯಾಶುವಲ್ ಆಗಿರ್ತಾರೆ. ಪ್ರತಿ ಒಂದು ಸೆಂಟೆನ್ಸ್ ನಲ್ಲೂ ಪ್ರತಿ ಒಂದು ಮಾತಿನಲ್ಲೂ ಅವ್ರಲ್ಲಿ ಕೆಮಿಸ್ಟ್ರಿ ಕಾಣಿಸ್ತಾ ಇರುತ್ತೆ, ಗೊತ್ತಾಗುತ್ತೆ. ಹೇಗೆ ಕೆಮಿಸ್ಟ್ರಿ ನಾವು ಪ್ರತಿ ದಿನದ ನಿತ್ಯ ಜೀವನದಲ್ಲಿ ಹೇಗೆ ಅಪ್ಲೈ ಮಾಡ್ಬೇಕು ಅನ್ನೋದನ್ನ ಬಹುಶಃ ನಾವೆಲ್ಲ ಕಲ್ತಿದ್ದು ಕೂಡ ಅವ್ರ ಮೂಲಕನೇ. ನಾನು ಇಂಥದ್ದೊಂದು ಮಾಡ್ಬೇಕು ಅಂತ ಅನ್ನೋದಕ್ಕೆ ಯೋಚನೆ ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚಿತವಾಗಿ ಅಲ್ತಾಫ್ ಗೇವ್ ಮಿ ದಿ ಐಡಿಯಾ. ಸರ್, ನಾವು ಲರ್ನ್ ಟು ಲರ್ನ್ ಅಂತ ಹೇಗೆ ಕಲಿಬೇಕು ಅನ್ನೋದೇ ಬಹಳ ಜನಕ್ಕೆ ಗೊತ್ತಿಲ್ಲ ಈಗ. ಆದ್ರಿಂದ ದಯವಿಟ್ಟು ಈ ತರದ್ದು ಒಂದು ಸೀರೀಸ್ ಮಾಡಬಹುದಾ ಅಂತ ಒಂದು ಐಡಿಯಾ ಕೊಟ್ಟ ತಕ್ಷಣ ಜನ ಜಸ್ಟ್ ಥಾಟ್ ಎಸ್ ಇಟ್ಸ್ ಎ ಗುಡ್ ಐಡಿಯಾ, ವೈ ನಾಟ್ ವಿ ಟ್ರೈ ದಿಸ್ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಇಮಿಡಿಯೇಟ್ಲಿ ವಿ ಸ್ಟಾರ್ಟೆಡ್ ವರ್ಕಿಂಗ್ ಇಟ್ ಔಟ್. ಬಹುಶಃ ಫಾರ್ಚುನೇಟ್ಲಿ ಬಿಕಾಸ್ ಆಫ್ ದಿ ಲವ್ ದಟ್ ಮೈ ಫ್ರೆಂಡ್ಸ್ ಹ್ಯಾವ್ ಫಾರ್ ಮೀ, ನಾನು ಯಾರನ್ನ ಕೇಳ್ಕೊಂಡ್ರು ಕೂಡ ತಕ್ಷಣ ಅವರು ಇದಕ್ಕೆ ಸ್ಪಂದಿಸಿದ್ರು, ಇದಕ್ಕೆ ಒಪ್ಪಿಕೊಂಡ್ರು, ಖಂಡಿತವಾಗಿಯೂ ಮಾಡೋಣ ಸರ್ ಅಂತ ಹೇಳಿದ್ರು. ಹಾಗಾಗಿ ಮೊದಲನೇದಾಗಿ ನಾನು ಐಡ್ ಲೈಕ್ ಟು ಥ್ಯಾಂಕ್ ಆಲ್ ದಿ ಸ್ಪೀಕರ್ಸ್, ನಾಟ್ ಜಸ್ಟ್ ಪ್ರೊಫೆಸರ್ ಘನಶ್ಯಾಮ್ ಮೊದಲನೇ ಟಾಕೇನೆ ಕೊಡೋದಕ್ಕೆ ಒಪ್ಕೊಂಡಿದ್ದು. ಅವ್ರೇನು ಸ್ವಲ್ಪ ಹೆಸಿಟೇಟ್ ಮಾಡ್ತಾ ಇದ್ರು, ಮೊದಲನೇದು ಬೇಡ ನನ್ಗೆ, ಎರಡನೇದು ಮೂರನೇದು ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳ್ತಾ ಇದ್ರು. ದೆನ್ ಅಲ್ತಾಫ್ ಟೋಲ್ಡ್ ಮಿ ಇಲ್ಲ ಸರ್, ಯು ಸೆಟ್ ದಿ ಸ್ಟೇಜ್ ಅಂತ ಹೇಳಿದೆ. ಅದರಿಂದ ಹಾಗೆ he started the lecture. I'm happy that Professor Ghanshyam started this, and thanks for all the information that you gave. You have set this one rolling, and let's hope we'll have an excellent series. ಎಲ್ಲ ಟಾಕ್ಸ್ ಹೀಗೆ ಇರುತ್ತೆ, ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೂ ಉಪಯೋಗ ಆಗುತ್ತೆ. ವಿದ್ಯಾರ್ಥಿಗಳಷ್ಟೇ ಅಲ್ಲ, ನಾನು ಇದನ್ನ ಹೇಳಿದ ತಕ್ಷಣ ತುಂಬಾ ಜನ ಟೀಚರ್ಸ್ ಕೂಡ ನನ್ನ ಕಾಂಟ್ಯಾಕ್ಟ್ ಮಾಡಿ ದಯವಿಟ್ಟು ನಮಗೆ ಲಿಂಕ್ ಕಳಿಸಿ, ನಾವು ಈವನ್ ವಿ ವುಡ್ ಲೈಕ್ ಟು ಲಿಸನ್ ಟು ಆಲ್ ದೀಸ್ ಟಾಕ್ಸ್ ಅಂತ ಹೇಳಿದ್ರು. ಬಿಕಾಸ್ ಹೌ ಟು ಲರ್ನ್ ಅನ್ನೋದು ವಿಲ್ ಹ್ಯಾವ್ ಟು ಲರ್ನ್ ಟು ಟೀಚ್ ಆಲ್ಸೋ. ಹೇಗೆ ಪಾಠ ಮಾಡಬೇಕು ಅನ್ನೋದನ್ನು ಕೂಡ ಕಲಿಬೇಕಾಗುತ್ತೆ. ಹಾಗೆ ಅದಕ್ಕೂ ಕೂಡ ಸಾಕಷ್ಟು ಹಿಂಟ್ಸ್ ಕೊಟ್ಟಿದ್ದೀರಾ, ಅನೇಕ ಹಿಂಟ್ಸ್ ಇನ್ನ ಬೇಕಾದಷ್ಟು ಜನ ಕೊಡೋರಿದ್ದಾರೆ. ಅದನ್ನೆಲ್ಲಾನು ವಿದ್ಯಾರ್ಥಿಗಳು ಹಾಗೂ ಅಧ್ಯಾಪಕರು ಎಲ್ರಿಗೂ ಇದು ಉಪಯೋಗ ಆಗುತ್ತೆ ಅಂತ ಅಂದ್ಕೊಳ್ತೀನಿ. ಸೊ ಐ ಥ್ಯಾಂಕ್ ಒನ್ಸ್ ಅಗೇನ್. ಇನ್ಫ್ಯಾಕ್ಟ್ ನಾನು ಬಿಗಿನಿಂಗ್ ರಿಮಾರ್ಕ್ಸ್ ಮಾಡುವಾಗ ಐ ವಾಸ್ ನಾಟ್ ಹಿಯರ್. ಸ್ವಲ್ಪ ಹೊರಗಡೆ ಎಲ್ಲ ಹೋಗಿ ಬರೋದು ಸ್ವಲ್ಪ ಒಂದು 5-10 ನಿಮಿಷ ಡಿಲೇ ಆಯ್ತು. ಹಾಗಾಗಿ ಐ ಲಾಸ್ಟ್ ದಿ ಆಪರ್ಚುನಿಟಿ ಆಫ್ ಇಂಟ್ರೊಡ್ಯೂಸಿಂಗ್, ಬಟ್ ಐ ಆಮ್ ಹ್ಯಾಪಿ ಪ್ರೊಫೆಸರ್ ಸಂಪತ್ ಕುಮಾರಿ ಇಂಟ್ರೊಡ್ಯೂಸ್ಡ್ ಪ್ರೊಫೆಸರ್ ಘನಶ್ಯಾಮ್ ಅಂತ ಕೇಳಿದೆ. ಆಮೇಲೆ ದಟ್ಸ್ ಸೋ ನೈಸ್. ಅವ್ರು ಮಾಡಿದ್ದು ಒಳ್ಳೇದಾಯ್ತು. ಹಾಗಾಗಿ ಥ್ಯಾಂಕ್ ಯು ಎವ್ರಿಬಡಿ. ಥ್ಯಾಂಕ್ ಯು ಎವ್ರಿಬಡಿ. I thank also Dr. AHR who inaugurated these series and all the people who have been working in the background. ಇದು ಸುಮಾರಾಗಿ ನಿಮಗೆ ಬಹಳ ಜನಕ್ಕೆ ಅರ್ಥ ಆಗದೆ ಇರ್ಬೋದು. ಈ ತರದ್ದು ಒಂದು ಸೀರೀಸ್ ಮಾಡೋ ಒಂದು ಟಾಕ್ ನಾವು ಅರೇಂಜ್ ಮಾಡ್ಬೇಕಾಗಿದ್ರೆ ಅದ್ರ ಹಿಂದೆ ಎಷ್ಟೊಂದು ಕೆಲಸ ಇರುತ್ತೆ ಅನ್ನೋದು ಬಹಳ ಜನಕ್ಕೆ ಅರೇಂಜ್ ಮಾಡಿದವ್ರಿಗೆ ಅಷ್ಟೇ ಗೊತ್ತಿರುತ್ತೆ. ಇದ್ರ ಹಿಂದೆ ನಾವು 10-12 ಟಾಕ್ಸ್ ಅನ್ನ ಮಾಡ್ಬೇಕು. ಅದನ್ನೆಲ್ಲಾನು ಕೋಆರ್ಡಿನೇಟ್ ಮಾಡ್ಬೇಕು, ಬೇರೆ ಬೇರೆ ಟೈಮಿಂಗ್ಸ್ ತಗೊಳ್ಬೇಕು, ಬೇರೆ ಬೇರೆ ಸಬ್ಜೆಕ್ಟ್ಸ್ ಅನ್ನು ತಗೊಳ್ಬೇಕು, ಅವ್ರ ಬಯೋಡೇಟಾ ತಗೊಳ್ಬೇಕು. See, there is a lot of work that's going on, and all that has been done by Altaf and his team. I'm thankful to all of those people, all those people. Thank you, Altaf. Thank you, Professor Ghanshyam, and thank you, Professor Sampath Kumari and others. Thank you.
Yeah. Okay. Thanks, sir. Thanks.
Yeah.
So. Right. Yeah, I think we will go ahead with our next speaker for the next lecture, Dr. Malte Shakur. He has joined us. I welcome you, sir. Can you please unmute?
Yeah, I saw him. Yeah. So nice. So nice. Akur, Malte Shakur, tumba thank you for joining us. I'm so happy. After a lot of number of years, I'm seeing you back. ಬಹಳ ವರ್ಷಗಳೇ ಆಗಿ ಹೋಗಿತ್ತು ನಿಮ್ಮನ್ನ ನೋಡಿ. ಐ ಆಮ್ ಹ್ಯಾಪಿ ಯು ಆರ್ ಬ್ಯಾಕ್ ಅಂಡ್ ಯು ಆರ್ ವಿತ್ ಅಸ್ ನೌ. ಥ್ಯಾಂಕ್ ಯು ಮಲ್ತೇಶ್. ಐ ಥಿಂಕ್ ಅಲ್ತಾಫ್ ವಿಲ್ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಯು.
ಯಾ ಶೋರ್ ಸರ್. ಅನ್ಮ್ಯೂಟ್ ಮಾಡ್ತೀರಾ ಮಾಲ್ತೇಶ್ ಸರ್? ಯು ಆರ್ ಅನ್ಮ್ಯೂಟ್.
ನಾನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ನಾನು
ಸಾರಿ ಸರ್. ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಮೇಡಮ್. ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಟು ಆಲ್. ಅಲ್ತಾಫ್ ಸರ್ and all.
Yeah. So our next speaker is.
I'm audible?
Yes, sir, you are audible. Allow me to introduce you to the audience. Dr. Malte Shakur, he is the Associate Professor in Electronics in the Department of Electronics at School of Sciences in Jain University, Bangalore. He completed his MSc, then MPhil, then he did a B.Ed and finally PhD. PhD he completed from Jain University itself. And he specialized in embedded systems, e-learning, fuzzy logics, control systems, robotics, renewable energy systems, which is also my field of interest, computer networks and wireless communication. Overall, he comes up with 20 years of teaching experience in undergraduate and 5 years as a faculty in postgraduate studies. He also has overall several publications, around 16 to 18 publications in his credit, and has been awarded Inspiring Teacher Award from various institutions like Garden City College. I think there are a lot of attributes to Dr. Maltesh. Without further ado, I would hand it over to Maltesh sir to start his lecture. We are starting at 11:34 and we shall conclude it more or less by 12:30 or 12:35. Over to you, sir.
Yeah. Thank you, Altaf sir. So can you allow me to share the screen, please?
Yeah, give me 1 second. Yes.
Yeah, good morning to all. In the morning, I called Altaf sir and just inquired about the audience, whether the public or the students. So most of the first and second PUC students will be there, he said. So I'm going to concentrate few basics on the PUC level, and of course how we can do some projects and all. So electronics, for you, just I'm giving the topic to it. First, let us see what is electronics. So in the long back, most of you might have studied. So what is electronics? So long back, we used to define it as the branch of science and later the branch of physics. But now it has become the branch of engineering, okay, and which deals with the study of behavior of electrons in the gases, vacuum, and the semiconductors. So basically, once the semiconductors came into the invention, so the vacuum tubes and all not being used. So the size of the computer and all the electronic devices is going to be reduced. So before we were using the vacuum tubes, the size of the vacuum tubes and all the electronic devices were bigger. So we see the size of a computer was like almost a room, but now the size of the computer is the palm level. That is the mobiles. So we can say the mobile is a computer because usually a computer will have the CPU, I/O devices, and memory and processor and all. So of course, mobile has all those things now. Okay, so I/O devices are there and memory is there and the processors are there. So the size is going to reduce because of this the semiconductor technology. Okay, and we also can say it's the use of the electricity for measurement, control, communication, and all lot more. And most of the applications already we know, like alarms, LED lights are there, calculators, televisions, and we can mention the lot. Okay, in almost all the fields, the electronics is being used. So of course, these are all the devices which are nothing but the electronic devices. Of course, we're going to invent the chips that can be behaving like the sensors. So to do the lot of applications. Whenever we see the electronic circuits and sensors, that first comes into the mind all the electronic components and the ICs. Okay, and I think heard about this the Moore's law. So it's going to be even now also it's going to be the true. What is said according to the Moore's law, after every 2 years, the number of components that can be the fabricated in a particular chip or the IC is going to be doubled. Okay, so a little more accurately, after every 18 months, the number of the transistors that can be the fabricated in a particular IC is going to be doubled. So it is going to be the true even now also. So the technology is going to be, so as the number of components are more in a particular same, that is a square millimeter. So of course the features will be the more. Okay, so that's what we're going to see in almost all the fields of the electronics. So just to mention few the components, that is a resistor, capacitor, and the inductor. We call them as the passive components, and all the semiconductor components are what the active devices like diode, transistor, and all the ICs. And here to mention the relay. The relay is nothing but the switch. So it is an electromagnetic switch, what we call it as. Okay, so to handle the high voltage and high current, we go for the relays. Okay, so using the IC, just the 5 volts DC supply, but we can't operate the high voltage devices like which run on the AC. So to run the AC devices or the high DC voltage devices, so we go for the relay operation. And of course, the power supply is the battery is required. And the sensors are the very important in any the embedded system or the electronic devices. So this is going to the behave like our eyes, ears, and all those things. How very important for us. So usually through the eyes, ears, and all those things, we receive the signal from the external world and send it to the brain, which is the processor. And the brain will take the decision depending on the sensor measurements, and it gives some instruction to the actuator, which are the hands, legs, and all those things. Same concept. So the sensors play a very important role, okay, to convert the physical quantity into electrical quantity in terms of either voltage or the current, and that will be sent to the processor, and the processor will take the action depending on the program we write. So inside the memory, and depending on that the instructions, the processor will take the decision and give the some instruction to the actuators. We'll see. These are some of the major sensors in most of the projects or the systems we try to use, like the ultrasonic sensor, gas sensor, color sensor, PIR sensor, accelerometer, and all these things. Okay, here the most of using the auto, for example, using the ultrasonic sensor, we can measure the distance so between the object and the sensor. It will send a wave and it will calculate the time and then calculate the distance, and it will give the instructions how ahead it is. So such sensors are going to be used in obstacle avoiding robots and for the equipment for the blinds and all, and to identify the depth of the particular the water level in the tank or the well or something like this. Okay, the gas sensor, it will identify whether the leakage of the gas is there and so on, lot more. So all these have the LDR is the light sensor, and the flex sensor is a register. Basically it is the resistance depends on the flexibility, it is a curvature. Okay, so as the bending changes, its resistance is going to change depending on that. So we try to identify whether the say floor or a particular plane is the bent or the flat or something like this. Okay, this is the IR transmitter and IR receiver. If you club together, so it will form an IR sensor. So it's going to found in the some of the burglar alarms or the security systems or the line following robot or something like this. Okay, and LM35 the temperature sensor. Okay, and this is the thermally sensitive register. And the most of the sensor, this is a Hall sensor, is going to be used to the flow of the current or the magnetic field, the presence of the magnetic field, so we can identify. Some of the actuators, they are different. The actuators are nothing but, as the name indicates, what it does. These will do some action. Okay, there are electrical actuators like motors and all, and hydraulic actuators and pneumatic actuators. These hydraulic actuators will use the fluid to amplify the control command signal, and the pneumatic actuators will use the compressed air. So we're going to see in most of the industries and the vehicles, automatic door locking system and the opening systems. Processors. So we're going to see the lot of processors in the system as well as in all the embedded system. So these three are very important. There is a processor, actuators, and sensors will play very important role in the any embedded system. These are very much required. Of course, the memories also. So this is the overview of the processors, how they evolved from the beginning. So the first company which is introduced the microprocessor to the world is the Intel. It started with the 4004 and 4040, 8008 and 8080 and so on with the different ICs. So it is for example here 8080 is a 8-bit processor. You can see the data width, the 8-bit, 16-bit and so on. The meaning of this 8-bit, 4-bit and so on indicates what? How many bits it can handle at a particular moment. Say for example, the 4-bit processor will handle only the 4 bits at a particular moment. 8-bit processor, of course, double of it, which is 8 bits, 16-bit and so on. Say for example, if I ask a question to you, what is 2 plus 4? So it is very easy to see, say 6. Okay, if I say 20 plus 30, so it is also the very easy 50. If I ask a question to you again, 248 plus 979. So it doesn't mean that it is not possible for you. It takes a bit of time. So you go for the digit wise. So you take the rightmost digit, which is in the unit place, and you go on adding it. In the same way, so our brain or the arithmetic and logical unit, that is ALU, what we call it as. So ALU means not the potato here. It is the arithmetic and logical unit in our brain. We can handle either one digit at a moment or the digit at a particular moment. So we have to take the 1 or 2 digits and add it and go to the left side. In the same way, this process also, the huge number, say for example, I can write a number on the board from the extreme left to extreme right, which consisting of the zeros and ones and zeros. So it is not possible to handle all those bits of one number and another number by the processor at a particular moment. So 8-bit processor will take only the 8 bits of one number, 8 bits of other number, add it, and again 8 bit of the other number and so on. So this is the way how these will work. So of course we are working in the 64-bit processors now, which are the Pentium series. So of course, as I said, the embedded systems will have the I/O ports and the processor and the timers and all those things. So timer is nothing but basically a register. The register is nothing but not the 1 kilo ohm, 2 kilo ohm I'm talking about here. It is a group of flip-flops. A flip-flop is a memory element which is made of the logic gates. Okay, in one flip-flop I can store 1 bit. If I want to store 4 bits, I need to use the 4 flip-flops. So in the same way, group of 8 flip-flops is what 8-bit registers, 16-bit registers, and all are there. Of course, the processor and the program memory should be there, and serial communication ports. Usually, to communicate to the external world, the processors are going to use serial communication, means 1 bit after another one. So they'll receive the bits in a serial fashion and convert into parallel inside the systems. Okay. And here the agenda is I'm going to show one of the Tinkercad. In this pandemic time, it is very important for us to learn the electronics. So I'm going to introduce one of the simulation tool, which is the Tinkercad, and I'll teach you how we can utilize it without using the components. We can learn a lot of concepts in the electronics. Okay, we can use all the components which are available in the Tinkercad, and you'll be excited. It will be easy for you and interesting for you people. I'm going to show one or two the electronics, analog circuits, digital circuit. Of course, the microcontroller, which is the Arduino microcontroller. I don't know how many of you use. I think a few might have used here at the PU level I'm talking about. You can build certain projects using the sensors and all. Okay, I don't know how the time permit. So within that, I'll try to teach one or two circuits in this Tinkercad. The first, the registers. I am not going to waste much time on this. The basic components are the registers. The different registers are there. I think you know the color coding of the registers. We have the certain the line. The BBRI of the Great Britain has a very good wife and all. Just remember the color coding of the registers. And here are some examples. Usually we follow this the procedure. The first digit indicate the first value of the color coded value, and the second color indicates the second digit. The third one is the multiply, and the last one is tolerance. Okay, for example, if the first the band is what the red, yellow, and the orange, and the last is the gold. The first digit is what 2, second is 4, and 10 to the power the orange is 3. So it becomes 24 kilo ohm. That is for 24,000. Usually, if the ratios are more than 1,000, we have the practice of expressing in kilo ohms, mega ohms, and all. And this tolerance, in a sense, is for gold it is a 5%. For the silver it is a 10%. And if no last band is not there, so by default it is 20%. So the 5% of this 24 kilo ohm we have to calculate. It comes around 1.2 K. So it is what 24 kilo ohm plus or minus 1.2 kilo ohm. So 24 kilo ohm minus 1.2 is what 22.8, and 24 plus 1.2 is what 25.2. Means according to color coding, the resistance value is what 24 kilo ohm. But if I measure it with multimeter or the ohm meter, it may not be exactly 24 kilo ohm. It may show any value between the 22.8 kilo ohm to 25.2 kilo ohm. That's the meaning of this. I think most of you might be knowing. Just these are some of the examples. Okay, using the same. Not going to waste much time on this. Yeah. So as I said, this is the Ohms law. So just to verify the Ohms law, we need the conductor or the resistor, the battery or the RPS, and one ammeter and voltmeter. We can build this circuit in the Tinkercad. There is a virtual lab, what we call it as. So here you can see I'm going to select on the right side, the picture is going to show on the Tinkercad circuit. And I'm going to use the 2 multimeters and 1 resistor and 1 RPS, which is the power supply. So we can connect in this way. One multimeter I'm going to use as a ammeter, and the other one as the voltmeter. Okay. So by changing the voltage in the RPS, I can read the current as well as the voltage across the resistor, and we can verify the Ohm's law. So we can, like this, we can do the diode experiments and all those things, like the forward bias, reverse bias. Here, the same circuit along with the Ohm's law. Just I'm going to use one diode, so which is connected in forward bias. So you can see the silver ring on the right side, that is the N type, or the cathode is connected to the negative of the RPS, and the positive is connected to the P type store. So we can say it's a forward bias. You can see the readings. The current is going to show. I'm going to show this in the Tinkercad later. Just to go through the readings now. Current is 0, and the voltage is what? 399 millivolts. Okay, means 0.399 volts. So we know the diode is the very important device which operates in a single direction. Means it allows the current to flow in a single direction, which is the main application of this diode is what? The rectifier. Okay, so when it is forward bias, it connects. When it is reverse bias, it won't. And the knee voltage, I think you are aware of it. The knee voltage, the forward voltage at which the diode starts conducting. Okay, for silicon diode it is 0.7, and for germanium it is 0.3 volt. You can see here the voltage, the 0.399 volts is there across the diode, but the current is 0 because it is not going to cross the knee voltage. Okay, as I increase the voltage, now it is a 0.527 volts. A small current, which is in microampere now, so we can say it is a 0.733 microampere. Okay, now it is still I have increased a little bit the voltage across the diode, which is 0.558. It is in millivolts actually. Now it is a 558 millivolts. If you convert into volts, is what? 0.558, and a small current is there now. Okay, that is a 2.42. Before is the microampere. You can see this is a previous reading, 733 microampere, but now it is a little more, and next will be still less, and so on. So once it crosses the new voltage, so current will be more. We can build such circuits also.
Sir, can you unmute yourself?
Yeah. Sorry for a moment. Just. Yeah, I'm audible.
Yes, sir, you are.
Yeah. Okay. Just to listen this, how we can. I'm going to tell how we can utilize the Tinkercad. Just go to the Google search in the Chrome and type on the Tinkercad. It works a bit slow. The screen is visible, right?
Yes, sir.
The screen is visible, right? Hello.
Yes, sir, it's visible.
Yeah, fine. So go to the Chrome and type the Tinkercad, and it will ask the login through the Google. Just I'll show that step. That is very important. I'll log out. Actually, it was logged in. So log out and log in once again. Yeah. So once you click the Tinkercad, it'll reach this page and go to the sign in. Sign in with Google. Can you use any of your Google, that is a Gmail ID? Okay, so we'll reach this page, and you can see you can select the photos and all, how we set it for other apps and all. Just here, my name, just 3D designs are there, circuits, code blocks, and lot more are there. Just to go to the circuits, click on the circuits. Okay, so when you click on the circuits, all the circuits what and all you have designed will appear there. If not, it will be the blank. Okay, and click on the create new. Okay, so this is the workspace we'll get. Here you can see on the right side, there are the list of the components which is available. So you can scroll down, the basic components and all the components are, the options are there. You can see. So basic and the all components. If you click on all the components, which are the components present in the Tinkercad, we can see it here. And we can utilize those and build the circuits. I'll go for the basics. Just I'll show you one or two, and later you can practice it. Now I'll take an LED. Okay, so if you click, move the terminals, mouse towards the terminals, it will show the terminals. There is a cathode and the anode. And I'll take a register. Okay, and connect the wire. Just to click it and drag it down, the wire will be connected. You need not to select the wires there. And I'll take a battery. You can rotate the components according to your convenience. Just I'll click this and extreme left side, rotate it. Okay, and this is the negative and this is the positive. So we know this is the cathode and this is anode. The anode should be connected to the positive of the battery, and this should be connected to the negative. Okay, on the right side you can see the code is there, and the start simulation is there. Okay, so the code, in the sense, if you're going to use any the programs for the microcontroller and all, we'll have to see it. And here is not the non-programmable. And one more thing, I can select the color of the wire also. If you click on the wire, you can see on tab, you can select any of the, for positive, let's use the red. And for negative, let's go for the black. The same way, you can select the register value. So by default, it will be 1 kilo ohm. You can select like 220 ohm and so on. There's a kilo ohm now. You can, now it is a 220 ohm, and you can give the name also for that. That is like R and something like this. And if you click on the LED, you can see which are the colors you want. There's a green, yellow, and so on. So these are the available colors. You can go for the green, any color. Okay. Now click on the start simulation right side at the top. Okay. here you can see the start simulation is there, and we can the export and share the project what we build here. Now I'll click on the start simulation. You can see the LED is on. Okay, so instead of this register, so we can select the we can connect a potentiometer also to vary the its intensity. Okay, let's stop this, stop simulation, and select the potentiometer. Here is the potentiometer. Just click on this to remove the component. Just click on it and delete it. Okay, those connections will go. And now, I'm going to use this as the variable register. So we can use along with the wiper, which is the middle terminal, either the terminal 1 or the terminal 2, we can utilize it. Connect it here. Just in place of the register, I'm going to use the potentiometer. Now I'll click on the simulation. Okay. See, resistance is more now. See, now it is the LED is when the resistance is less, the LED is glowing. Of course, the resistance value of this potentiometer is more. By default, it will be 250 kilo ohms. So now we can reduce it like 1 kilo ohm or something like this. I'll make it as 1 kilo ohm. Okay, now start simulation. Can give. Okay, so now you can see. So as I reduce the resistance, the value is going to, the intensity is increasing. And after some resistance, when the resistance is less, the huge more current is going to flow beyond the rate of LED ratings. So it's a burning symbol what it is going to show. So this is the one of the application. In the same way, we can build the Ohms Law circuits and so on. Now onwards, I'm not going to show the building of the circuits because the time limit is there. I'll try to show the other circuits what we can do. This is a stable multivibrator using the 555 IC. Okay, and here this is just R1, R2 in the same way how we build the stable multivibrator. The same circuit it is now. Here instead of one register, I have connected the one potentiometer. Okay, and this is the power supply, and buzzer is being connected between the output terminal, which is pin number 3, and the ground. Okay, if I simulate this, so we can here build the buzzer. Hope you are listening to the sound. So usually in the bells and all, we can, horns and all, we can utilize this concept. By varying the resistance value, we can change the resistance. You can see now, just this is 250 ohm. It is you can go for a 10 kilo ohm potentiometer. Yeah. Hope you are listening to the sound. Okay, this is the one of the application of the analog circuits, and also we can use the transistor as a switch and logic gates and all. So I'm not going to show it now because it's already the 12. Just I'll go to the microcontroller, which is the Arduino, and how we can utilize the Arduino. Just I'll show you. Go to the new circuit. And type here Arduino. bring it here. Okay, so this is the Arduino. Before that, just I'll give an overview of the Arduino in the PPT. I'm going to skip all these things which are not required. So for a small difference between the microprocessor and microcontroller, usually we call them as the microprocessor is a single the CPU of a microcomputer, but the timers and I/O ports and all will be the external, means other ICs. But in the microcontroller, all these components are available in the single IC or the single chip, what we call it as. Therefore, we call the microcontroller as an on-chip computer. Means in a single chip, the complete all the units will be there. These are the same differences what I said now. Say this is the Arduino, the development board. So we can, this Arduino microcontroller software is open source, means it is a free of cost. You can download the IDE on the system and we can work on that, can write the program. There are different versions of the Arduino are there. The popular are what? The Arduino, Leonardo, Lilypad, Mega, Nano, Mini, Mini Pro, and so on. This is is the popular for and is very good for a user, the starter, okay, with the Arduino. Once you are the perfect with this, it is easy to go with the other controllers. Now you can see here. It has the 14 digital I/O pins are there from 0 to 13. Okay, so these are the digital pins, and these are the analog pins here. The bottom A0 to A5 are the analog pins, and these are the power supply connections: ground, 5 volts, and 3.3 volts. And through this is the DC power jack to which we can supply the power using 9 volts battery or adapter. We can connect it. And this is the USB jack through which we try to transfer the program from the laptop or the system. Okay, and this is the reset button. If you press it, the program will start from the beginning. This is the crystal which will decide the speed of the system. There is a 16 megahertz crystal is there, and there are some built-in LEDs are there. This is a TX and a transmitter and receiver LEDs. Whenever you transfer the program or whenever there is a communication from the microcontroller to other I/O devices in serial through the serial monitor, these LEDs will be the blinking. There is the built-in LED which is connected to pin number 13. The digital pins, in a sense, these are the I/O digital pins. In a sense, the voltage will be always the 5 volts or 0 volts in this case. So we can utilize these as the input pins or the output pins. So to connect the sensors and all, we have to configure these as the input pins in the software. To connect the output devices, we have to configure them as the output. Okay, and these are the analog pins. So again, we can make these as the input or the output. Okay, now I'll show you the simple procedure how we can start with the Arduino is what: download and install the Arduino environment, that is IDE, which is open source, and connect the board through USB and install certain drivers which are required for the software, which these are nothing but the softwares which are required depending on the application we use, and the launch IDE and the select the board, means which kind of the board, whether it is a or a Mini Pro or something like this. Okay, and we have to select the serial port and to which it is connected. Then we should write a program and compile it. It is a save it and compile it. Okay, as you know, the compilation is what is the process of converting the high-level language into the low-level language. Here we're writing the program in C, which what we call it as embedded C. Okay, and we have to upload, and the program will be transferred to the internal memory of the microcontroller. And this Arduino microcontroller has Arduino is not a microcontroller, it is a development board, but it has a microcontroller, what we call it as Atmega 328. So it is going to operate on the 5 volts, and we can supply the 7 volts to the 12 volts to it. But internally, there will be the converter from the high voltage to the 5 volts, which is the IC regulator. Okay, And the input voltage range from 6 volt to the 20 volts for analog. And as I said, the 14 digital pins are there, 6 analog pins are there, and these are the current around 40 milliampere. For the DC current for the 3.3 volt pin 15 milliampere, and memory is 32 KB, and the SRAM is 2 KB, EEPROM is 1 KB, and the clock speed is, as I said, the 16 megahertz. The first program, let us see how the program will be look like. So this is, go to the first program. Yeah, this is the first program, what we call as the blink program. Blink in a sense, just to, I want to make an LED on and off. Here, as I said, the pin number 13 is connected to the pin number 13. There is an inbuilt LED. So we try to the blink it. Okay. So before that, so the program has, every Arduino program has two sections or two parts. The first section is what the setup block, what we call it. The second one is the loop. Okay. The setup block is going to execute it only once. Okay. And the loop block is going to execute continuously, because all the embedded systems so will have to run on their own continuously. So the, say for example, temperature sensor, it has to read the temperature frequently. Okay. And should take the decision and give some actions, some commands to the actuators. Now here, I'm going to use the pin number 13, and we have to configure it as the output. Okay. So the command for it is what? The pin mode is a case sensitive 13 comma output. And in the loop section, of course, the command lines are being written like how we do in C programming. The digital write 13 high, delay of 1000 millisecond. It is a millisecond, so it is a 1 second. Okay. So digital write low, and the delay of again 1 second. Now here, what is happening? When the LED is connected to the pin number 13, when a high voltage is sent to it, so it will glow. It will be on. Wait for 1 second, and send low voltage on the same pin. So LED will be off, and wait for 1 second, and again comes back to the first instruction in the loop. It will, the control will never go back to the setup block. Okay, it's going to be executed only once. Usually in the setup block, we try to use which are the pins we are using, and whether they are input or output, we try to configure that. Okay, and actual actions will be in the loop block. Okay, now let us see how we can utilize this in the Tinkercad software. Yeah, so I took the Arduino pins. I think you are aware of this time. Let's, as I said, to pin number 13, the inbuilt LED will be the connected to it. And now the code, by default, the blink program will be available. Okay, just to click on the code and click on the blocks. You see the options, blocks, blocks plus text, and text will be there. Click on the text, you'll see the program. Click on continue. Yeah, this is a program. As shown, the same program it is. So setup, pin mode 13 output, and the digital write 13 high, delay of 1 second, digital write 13 low, and delay of 1 second, and so on. Now click on the start simulation. Now you can see the LED is the blinking now, so which is just below pin number 13. This is that LED below the ground, and 13 is there now, so that LED. So we can use the external LED also. Now I'll connect the external LED and show you. Let's take an LED. And let's connect a register in series with the okay. So just connect the wires, and this is, you can see, this is the cathode and this is the anode. Okay, the cathode, let's connect the cathode to the ground. This is one more ground is here, And let's connect this to pin number 13, because in this particular program, pin number 13 is being used as the output. Of course, as I said, we can change the colors of the wires also, red and the black and so on. That's fine. Now I'll go for the simulation. Start simulation. Okay. So this is the LEDs, the blinking. So this is one of the simple application how we can utilize. I can change the other pins also, but instead of 13 in the program, I have to change the corresponding the pin there. That's it. Now, here's some other applications. Usually this Arduino microcontroller, what and all we can build this. So we can build the robotic dog and obstacle avoiding robots. Okay, and with multiple sensors. And this is the line following robot. And this is the robotic snake and cleaning robot, the Bluetooth controlled robot. So we can control the movement of the robot using our phone, Bluetooth. Okay, and the watering pick and place robot, the humanoid robot, and the traffic light control system, the Bluetooth controlled home automation. Means from our home we can send the commands to the Bluetooth, and the Bluetooth will be connected to the Arduino, and depending on the command we give, we can switch on and off the devices in our home, and we can connect the GSM module for the same, and it becomes what the IoT project. So the ACs, so all the devices which are running on AC, we can control. This is the, as I said, this is the GSM module. Okay, is a SIM 900 or SIM 800 is a GSM module. So usually once you connect it, it is possible to operate the devices anywhere from the world. Okay, and these are the, and we can build the quadcopter. Okay, that is a drone, and we can realize the virtual reality just by moving the hands, can move the objects. So this is a one example. That is a traffic light the control system. Just because the time shortage there, I tried to show a few circuits. This is the traffic light control system with the 3 LEDs. As you can see, the red and yellow and the green I'm going to show. Actually, this is the extension of the blink program. Okay, I tried to keep the green LED for a few seconds on, and other 2 will be off. And next, the yellow should be on before transferring to the red for a few seconds. Other 2 should be off, and then next the red should be on, and other 2 should be off for a few seconds. And this sequence should repeat. For this, the program is the same. You can see it, as I said, all the programs will have the 2 blocks. That is the setup and the loop block. Here, the pins 2, 3, 4 are going to be used, and accordingly connected to the different color LEDs. And you can see the blocks, different blocks in the loop. I can call it as the block 1, block 2, block 3, and block 4. So this is the green is high here, and here is yellow is high. It means yellow is on, we can say. This is red is on. Okay, so this is this is the green. From green to red, it has to transfer, but in between, the yellow should be for a short period. And then from red to green transfer. So again, the small delay of the yellow is there. You can see there the digital write to high, because for pin number 2, the green LED is connected, so it is high, and other 2 low. Low means 0 volts are sent, and high means 5 volts are sent on those particular line pins. And delay of what, 5 seconds here. So 5,000 milliseconds. So it is a 5 second. And again is what next yellow is on for what, just 3 seconds. Should be for a short period. And again the red is on here. Other 2 are low, and again the yellow is on before transferring to the green. Again come back to the first block in the loop. So as I said, in the control will never go to the setup block. The setup block is going to execute it only once. Now I'll show this the simulation in the Tinkercad. The circuit is there. I'm not going to build it. So once you design any circuit, so it looks like this, and click on the left top corner, the Tinkercad, which is in the colors, it is there. Just to click on that, it will be saved. And the right side, the name is some junk name will be available. You can give her any name depending on the project. Yeah, this is the traffic light control system. So while it is running online, it takes a bit time. Yeah, you can see just 3 LEDs are there through registers. We can select any register. If the value of the register is higher, the current will be less and the intensity will be less. That is all. Okay. Now I'll click on this start simulation. The same program is there. Click here, the same program what I showed, let's say, is already there. So usually this, when we build the circuit, the program will not be available. Only whenever we use the Arduino board in the workspace, only the blink program will be there. But later we have to write the program or the copy and the paste it here if you already the program, depending on the application you are using. Okay. Now I'll click on the start simulation. You can see green is on now. It is set for 10 seconds. So it takes the more time. I can change it for 5 seconds. Right. You can see here, this is a 10 second is there. I'll make it as 5 seconds. And here 3 seconds and here. I'll do it 5 seconds. You can change it any moment. Okay. Yeah. The green is on for 5 seconds. You can see at the top the how many seconds over once we start the simulation. Now red is on, yellow is on, next green is on, and so on. This repeats. So this is only for one lane, and in the same way we can use 3 more for the another lane, or 4 for the 4 lane traffic light control system. This is the one application. Now we can see the interfacing of the ultrasonic the sensor, and yeah. This is the LDR application, that is a light dependent register. You can see here, depending on the light intensity, we can actually, in case of the street light control system, so these such applications are going to be used. So depending on the intensity on the LDR, so it produces the voltage, and LDR, as the LDR indicates is the register basically, but its resistance depends on the light intensity. So if the intensity is more, resistance is less, and vice versa. Okay. So using this concept, we can build the street light control system. Say for example, this is a street light. Of course, this is we are going to build some projects or the circuits which can operate. But if you want to scale it up for the bigger level as the real model, just we have to interface the relay to it. So say for example, this is the circuit which is the street light control system. For the output, just you connect the relay along with the relay drive circuitry, it becomes a real time application project. I'll try to simulate this. Before that, I'll show more application. Here you can see in the program. I think if I start explaining the program, it takes more time. Here I'm going to use the A0, which is the analog sensor, and it is made the sensor value is 0 in the beginning. These are the global variables which are outside the setup. This is also possible. And pin number, I'm going to use the pin number 13 and giving the name as what the LED, right? And this is the setup block. We try to configure the LED is output. The LED means what? So pin number 13. So instead of declaring this in the beginning, so we can write the 13 here itself. That's also fine. So to use the serial monitor, we try to use the baud rate of 9600. And to print something, welcome to the streetlight control system in the serial monitor. And this is the sensor value equal to the analog read sensor pin. The sensor pin is nothing but what? The pin number A0. Okay. And we try to compare its intensity, whether it is a less than 100, and we can do some actions and all. If sensor value is less than 100, so is what? The LED is on. Okay. For that, how to send write a digital write LED high. LED means pin number 13. Its meaning is what? Send a high voltage on pin number 13. So if the LED is connected to it, it will be on. And wait for 1 second. And the digital write LED low, just switch it off. So if the LED is, when the LED will become on, if the sensor value is less than 100. If you keep it else, if you write, it will be low, or if it is true, this will be the on. But here, just whenever the intensity goes below a particular the intensity what we mentioned in the program, so the LED will be blinking. That's it. Okay. This is the servo motors. Usually the servo motors will play a very important role in the robotics and the automatic door lock systems and all. So nowadays everywhere, whenever a person comes, the doors will be automatically the opening and closing. It is a combination of these servo motors and the ultrasonic sensors. The ultrasonic sensors will identify the object or the person, okay, and it gives the instruction to the controller, and the controller will give the instruction to the actuators like the motors to move up and down. So this is the servo motor connection. We can rotate it 0 to 180 degree and back to 180 degree. Here, if I connect the ultrasonic sensor to the same project, depending on the distance, if the distance between the sensor and the object is say around 12 centimeter or 13 centimeter, anything, the servo motor should rotate like 180 degree. Means it will open, is going to be used to open the door. And once the object is not there or the person is not there, it has to close back. Such applications we can build using these. So one application I showed here was just to look at the program. The servo motor we are going to use and connect it to the pin number 9 in this particular case. So we can use any of those pins in the output. And here, just I'm going to use the 2 for loops. This is a first for loop. The position is 0 and it's going to rotate till 180 degree. Okay, in step of 1 degrees. This is a simple C for loop. If you are aware of the C programming, it's easy for you. Just I'm going to increment by 1 degree. I can make it as 2 also, 3, which becomes faster. Okay, and in the beginning, the position value is what? 0, and that 0 is sent to the signal pin of the servo motor. It won't rotate. Next time it is 1, so 1 degree it rotates, 2, and so on until this condition fails. So it will wait for just 15 millisecond and reverse it again. So 180 degree to 0 degree. Here in the first for loop, 0 degree to 180 degree. In the second for loop, 180 degree to 0 degree. We are going to rotate it. Okay. I'll show you all these in one. I'll explain one more, which is the ultrasonic sensor. Okay. So this sensor will have the one transmitter and one receiver, what we call the transmit and echo. This ultrasonic sensor, one example is what say SR04. It has 4 pins. There is a VCC, which is 5 volts we can connect, and the one is the trigger pin and the echo pin and the ground. The VCC is 5 volts. The ground is 0, as usual ground, and the trigger pin is what through this it will send the ultrasonic wave. So usually these ultrasonic waves will travel the speed of the sound. Okay, and this is echo pin through which it will receive it, and it will calculate the time. first. So how much time is taken to send it to and hits the object and come back it. Okay, depending on that, it will calculate the distance, which is the divided by. We get the actual distance in centimeter, so we can convert it in centimeter. So these are the same pins at the explanation what I said now. Is the operating range, just we can apply the 5 volts, and it can be used to measure the distance from 2 centimeter to around 450 centimeter, but it's best within 2 centimeter to 80 centimeter. So many applications. Here I'm going to give the equation. Here you can see how it's going to calculate the distance. Is the velocity is what 340 the meter per second. As I said, the sound, the speed I said. So in centimeter is what the 34,000 centimeter per second. Just I'm going to multiply it by 10 power 6 minus 6, because here the microseconds are required to reach the target and come back. So just if I adjust the decimal points and all, it's come what 0.034 centimeter per microsecond. So finally, the last equation, have a look at it. S is the distance. The distance equal to the how much time is take, and 0 into 0.034 by 2. So by 2 is what? Just is going to calculate the 2-way. So just divide by 2. We try to use this equation. And here you can see this is one example. Here this is the ultrasonic sensor. This is the ultrasonic sensor, and this is LED, and this one buzzer is connected. So here what we see by clicking this ultrasonic sensor, so we can identify the object. Depending on the distance between the object and the sensor, we can switch on this buzzer or not, something like a burglar alarm or something like this. Okay, we can utilize this application. So here we can give the target like the 12 centimeter or 50 centimeter, something like. If the distance is less than 50 centimeter or whatever the distance we give target, this buzzer will start giving the sound. At the same time, the LED will be on. So now I'll try to show these simulations now. This is the servo motor application. So it takes a small amount of time. It's when it's working online. Yeah. So all the servo motors will come with the 3 pins. One is the red wire will be there, and the black wire will be there. Red is what 5 volts as usual, and the black is the ground, and this orange or the yellow color is what the output. Okay, it has to be connected to one of the pins of the Arduino. Now I'll just click on the simulation. I'm not going to explain the program. We have seen it. So you can see it is rotating 180 degree, 0 to 180 degree, and comes back. So in case of the automatic door lock systems, just we can make use it what to open it just 0 to 180 degree, and to close it again back. So and in the robotics and all, how many degrees a particular arm of the robot has to rotate. For such applications, we use it. So all these components are available in the Tinkercad software. We can just drag them and connect it. It's possible. Altaf, I'll get 5 minutes. Altaf?
Yes, sir.
I'll get 5 minutes.
Yes, sir.
Okay. Yeah, you can see if I click on the sensor, the object will be visible. So I can move this target towards or the way. You can see the numbers that is above the sensor, the 44.4 inches and 112.7 centimeter. So here the centimeters we can select it. Just I'm moving towards the object. Okay. Since time limit is there, just I'll see run this the PPT in a few more slides. This is the relay also can be utilized in the application. And relays are, as I said, to run the devices on the AC. Just you can see by giving the 5 volts, there is a high volts and the low voltage from the Arduino, we can switch on and off the devices. So this is the LCD interfacing to display some information and all. Okay, and temperature related interfacing, that is the temperature sensor is the LM35 or TMP36 interfacing can also be done. As I said, this is a Bluetooth some features. Using this, we can build the water level, the indicator or the controller to switch on automatically to switch on the and off the motor to run the water. Okay, this is the Bluetooth controlled the robot. As I said, it needs the motors which are connected to the wheels, the Bluetooth module, and the Arduino. Okay, and these are the motor drivers. Okay, to run the motor, to supply the high voltage to the motors, we can use the motor drivers. It's a program, automatic door lock system. As I said, this is the program for the. We can utilize it as the old digital voltmeter. Just to display how much voltage there in the DC voltage at a particular moment. The fire alarm we can build. So whenever the fire is there or the smoke is there, we can give the alarm, something like this. So it will be very useful in most of the buildings or in a campus. The PIR sensor is a motion sensor, means if someone passes nearby, so it gives the sound. So it is possible to. This is a wireless notice board. So it is using the GSM module. We can send a message anywhere from the world and it can be displayed on the notice board. This is a small level. We can scale it up to a higher level. Okay, and this is a GSM based home automation. You can see all the devices can be connected through the relays. Okay. And by sending the information to the GSM module, we can switch on and off the devices. These are the program contents. Okay, thank you.
Thank you,
yeah.
Sir. I would like to ask Professor K.S. Nataraj, sir, to give the concluding remarks.
ಕೇಳಿಸ್ತಾ ಇದೆಯಾ?
Yes, sir. Yes.
ಕೇಳಿಸ್ತಾ ಇದೆಯಲ್ಲ? ಓಕೆ. ಥ್ಯಾಂಕ್ ಯು ಪ್ರೊಫೆಸರ್ ಮಾಲ್ತಿ. ಇನ್ಫ್ಯಾಕ್ಟ್ ನಾನು ದಿಸ್ ಈಸ್ ವಾಟ್ ಐ ರಿಯಲಿ ವಾಂಟೆಡ್, ಬಿಕಾಸ್ ನೀವು ಮಾತಾಡ್ತಾ ಇದ್ದು ನೋಡ್ತಾ ಇದ್ದಾಗ ಅನ್ನಿಸ್ತು ನಂಗೆ ಎವ್ರಿ ಡೇ ಲೈಫ್ ನಲ್ಲಿ ಹೇಗೆ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಹಾಸು ಹೋಗ್ತಾಗಿದೆ ಅನ್ನೋದನ್ನ ನೋಡ್ತಾ ಇರಬಹುದಾಗಿ. ನೀವು ಯಾವುದನ್ನ ನೋಡಿದ್ರು ಕೂಡ ಯಾವುದೇ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ನೋಡಬಹುದು, ಯಾವುದೇ ಎಕ್ವಿಪ್ಮೆಂಟ್ ನೋಡಬಹುದು, ಮನೇಲಿ ಉಪಯೋಗಿಸ್ತಾ ಇರುವಂತ ಉಪಕರಣ ನೋಡಬಹುದು, ಎಲ್ಲದರಲ್ಲೂ ಕೂಡ ಹೇಗೆ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಅನ್ನೋದು ಬಹುಶಃ ಇವತ್ತಿನ ದಿವಸ ವಿಥೌಟ್ ವಿಚ್
ಪ್ರಾಬಬ್ಲಿ ನೋ ಲೈಫ್ ಎಕ್ಸಿಸ್ಟ್ ಅಂತ ಅನ್ಸುತ್ತೆ. ಬಹುಶಃ ಬಹಳ ಹಿಂದೆ, ನೂರಾರು ವರ್ಷಗಳ ಹಿಂದೆ ಯಾವುದೋ ಕಾಡಿನಲ್ಲಿ ಕಾಡು ಮಾನವ ಇದ್ದಾಗ ಬಹುಶಃ ಯಾವ್ದು ಬೇಕಾಗ್ತಿರ್ಲಿಲ್ಲ. ಇವತ್ತಿನ ದಿವಸ ಎವ್ರಿಥಿಂಗ್ is based on electronics and electronic devices. In fact, I'm reminded of my days when we were teaching electronics. They're olden days. ಈಗ ನಿಮ್ಮ ನಮ್ದಕ್ಕೂ ಸಾಕಷ್ಟು ಡಿಫ್ರೆನ್ಸ್ ಇದೆ. ಬಟ್ ಆದ್ರೂ ಕೂಡ ನಮ್ಮ ವರ್ಕ್ ಬೆಂಚ್ ಉಪಯೋಗಿಸ್ಕೊಂಡು ನಮ್ಮ ಹುಡುಗರು ಹೇಗೆ ವರ್ಕ್ ಮಾಡ್ತಾ ಇದ್ರು, ಎಲೆಕ್ಟ್ರಾನಿಕ್ ವರ್ಕ್ ಬೆಂಚ್ ಅಂತ ಇರ್ತಾ ಇದ್ದಾಗ ಕಂಪ್ಯೂಟರ್. ನೀವು ಹೇಳಿದ್ದು ಈಗ ಎಷ್ಟೊಂದು ಪ್ರಸ್ತುತ ಅಂತ ಅನ್ಸುತ್ತೆ. ಈ ಕೋವಿಡ್ ಟೈಮ್ ನಲ್ಲಿ ಬಹುಶಃ ನೀವು ಯಾವ ಲ್ಯಾಬ್ಗೂ ಹೋಗ್ಬೇಕಾದಿಲ್ವೇ ಇಲ್ಲ. ಯು ಕ್ಯಾನ್ ಡೂ ಆಲ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸ್ ಅಟ್ ಹೋಮ್. ಯು ಕ್ಯಾನ್ ಡೂ ಎನಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಆನ್ ಯುವರ್ ಕಂಪ್ಯೂಟರ್ ಅಂಡ್ ಲರ್ನ್ ಆಸ್ ಇಫ್ ಯು ಹ್ಯಾವ್ ಬೀನ್ ವರ್ಕಿಂಗ್ ಇನ್ ಎ ಲ್ಯಾಬೊರೇಟರಿ. ಅಷ್ಟೊಂದು ಮಾಡೋದಕ್ಕೆ ಸಾಧ್ಯ ಇದೆ ಅನ್ನೋದನ್ನ, ಆ ಸಾಧ್ಯತೆಗಳನ್ನ ನೀವು ತೋರಿಸ್ಕೊಟ್ಟಿದ್ದೀರಿ. ಐ ಆಮ್ ಸೋ ಥ್ಯಾಂಕ್ಫುಲ್ ಟು ಯು. ಹ್ಯಾಪಿ ದಟ್ ಯು ಅಗ್ರೀಡ್ ಅಂಡ್ ಯು ಸ್ಪೋಕ್ ಟು ಅವರ್ ಚಿಲ್ಡ್ರನ್. Thank you very much, Malte.
Thank you, sir. Thanks for an opportunity. Thank you, sir, and also the Altaf for the coordinator, and also for the NES and the National College. Actually, I'm from the same college long back, and I learned from you people who were the seniors there. I'm thankful to you. Thank you.
ಡಾಕ್ಟರ್ ರಾಮರಾವ್ ಅವ್ರು ಹೇಳ್ತಾ ಇದ್ರು, ನಮ್ ಕಾಲೇಜ್ನವರು ಒಂದಿಷ್ಟು ಜನ ಇರ್ಬೇಕಿತ್ತು. ನಾ ಹೇಳಿದೆ ಇವರೆಲ್ಲ ನಮ್ ಕಾಲೇಜ್ನವರು ಸರ್ ಅಂತ ಹೇಳಿದೆ ನಾನು. ಅದಕ್ಕೆ ಐ ಆಮ್ ಸೋ ಹ್ಯಾಪಿ. ನೀವು ಆಪರ್ಚುನಿಟಿ ಕೊಟ್ಟಿದ್ದಕ್ಕೆ ಥ್ಯಾಂಕ್ಸ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ರಿ. ಇಂಥ ಆಪರ್ಚುನಿಟೀಸ್ ತುಂಬಾ ಕೊಡ್ತೀವಿ ನಿಮಗೆ.
ಥ್ಯಾಂಕ್ ಯು ಸರ್, ಇಟ್ ಇಸ್ ಮೈ ಪ್ಲೆಜರ್.
ಥ್ಯಾಂಕ್ ಯು ಅಂಡ್ ಥ್ಯಾಂಕ್ ಯು ಸಂಪತ್ ಕುಮಾರಿ ಅವರಿಗೆ.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಮೇಡಮ್ ನಮಸ್ತೆ. ಥ್ಯಾಂಕ್ ಯು.
Maltesh, it's
Thank
a
you,
pleasure.
madam.
Aita,
Yes,
you were
yes.
for some time. Okay, good that you again came to talk to our children. It was nice.
Yes. Thank you, ma'am. Thank you.
Thank you.
Okay. Bye.
Thank you, sir. Nataraj, sir.
Sir, thank you, madam. But I must thank you because in the beginning I was a bit late. Bharat Gello, I was held up. And so you took over and you started the session. So, yeah, thank you. Thank you. So nice of you.
I hope our children enjoyed the talk.
Yeah. That we will find it out later. Yes, from the feedbacks. Yeah, okay. Thank you.
Okay, thank you.
Okay, Altaf.
Yeah, sure. So a final announcement that just like today, tomorrow we have physics lecture. It's at 10:30 a.m. Today there was a problem for a lot of people to join. I hope I'll sort it out tomorrow. Maybe you can join at 10:15 and we will give you the links so that you are on time with us.
10,
This I'll sign off.
50 no 15 appa.
12 it is 10:15. 10:15 if we can join. 10:30 we can start the lecture on time.
Okay, that's nice. That's okay. Okay.
With this we will sign off. Thank you for your participation.
Thank you.
Okay.